Mm. Ich hoffe, man kann mich schon hören. Ihr könnt mir kurz in den Chat schreiben, ob alles funktioniert. Très bien. All right. So, I want to keep this stream probably in English because some viewers will be native English speakers. Yeah, I already wrote in the title what I'm going to do in this video, in the stream, better. Mainly, I will try to plan out a kind of battery. Actually, let's look at the vehicle first. So this is something I had on my hands for quite a while now. Oh God, it's not synchronized yet. Do I have some pictures of it? Ooh. Let me see. Yeah, I'll have to quickly disable the cam for a second. All right, now it's uploading. So I can show you like how the actual vehicle looks in just a second. I don't have the pictures yet on my computer. All right, that should work. Let's try this out. My stand is pretty shitty, so I'll have to upgrade that in the future. Oh God. Something like that. Droid cam. It's completely out of focus. That's quite nice. I don't know what it's focusing on. All right, looks better now. So, just one quick second. All right, that picture's ready. So, these are like this is like the bottom side of the whole. Actually, let me look up this picture right here. All right, this one. So, this is like a big e-scooter. Looks like this. What I want to do is basically I stripped out the motor controller. The issue with this this was basically a prototype. Hold up 1 second. I'll check my live stream here on the other page. All right, should work like this maybe. Looks good, looks good. All right. So here's the e-scooter itself. Right. The main issue with this e-scooter was basically the power was terrible. There was like no torque behind the motor controller before that. Also, the motor controller had a quite weird control. So there was a lot of lag when you push down the throttle compared to when the motor was actually ramping up the torque. So there were a lot of like small different like issues with this e-scooter. Let me actually see. Ah, okay. It's actually, you can actually buy it. I didn't know that. So this is the e-scooter I'm talking about. It's called the City Bug. I have some kind of prototype version, I think, of this. I don't know exactly which version I have, but it's not like you can, also, at least the scooter I have, is not something you can just buy off the shelf. So it was never for sale, as far as I know. I have some sort of prototype version of this e-scooter. At least I think I have some kind of prototype version because this was something that was used in development and basically got tossed out. And somebody came up to me and was like, "Do you want to make a video about this? This is a scooter we won't be using in the future." Let's actually look at the website. I'm quite interested in how. I didn't think this thing was actually on the market. I initially thought this was just a weird prototype. Yeah, but you can actually buy it. Mine looks quite similar to this one. 48 volt batteries. Apparently mine doesn't have that. Mine has a 36 volt battery, so maybe they changed something, right? I don't know. What the hell is this? This looks amazing. Looks so stupid actually when you ride this. Alright. Yeah. Let me catch up with your comments basically. Yeah, it's going to be completely in English. So there will be some people from, I don't know, different kinds parts of the world, so I want to keep it general, and I hope English can be understood by everybody. I've built a bobby car with a that's cool. Actually, like some thought I had the other day is maybe I should make open like a small Discord or something, because I already have like different kinds of like we have a big WhatsApp group basically where me and my friends and a lot of the engineering people I worked with all share like our ideas and projects we're working on. And I think a fun part of that would be maybe like to also create like a Discord, so this can be public. I don't know, just an idea. Maybe I should do a Discord. Yeah, but at least yeah, let's get back to topic. This is the scooter I think I have. It looks quite similar to this one right here. I stripped down the plastics and everything. It's literally in the other room. I stripped out the plastics and everything. Pulled out the motor controller because, as I said, the throttle input was really laggy. It was terrible to ride. Like it was definitely not fun. Yeah, let's actually see. Yeah, I think that's it. These are some pictures of the motor. Also, we have like these for mounting the battery. This is quite a weird system, so I don't know how I can easily explain this, but I open Paint or some stuff like that. So when we look at the battery, it basically looks like this, right? Oh, okay, that's a terrible line. Something like this. And you obviously have some room in there, right? This is like the front wheel, this is like the rear wheel. You have there's the motor in here. And this is our space basically. And if we look at it from this side, right? It looks something like this. Let me actually think. Yeah, something like this. So this is kind of what the whole box looks like, and then it's basically from this side also. It's like this weird shape, something like this. I don't know, I'm not too good at drawing out, but this is basically the viewing point from this angle right here. So what we have here are these little metal pieces that basically slide into like the bottom of the whole battery pack, right? Like this. I'll switch to another picture right here. They slide in from this side, and then you basically have all these metal pieces inside here. Yeah, so that's something. And you have some screw holes on here, so yeah, that's how the whole thing gets tightened down. I love how you basically found the algorithm tick. No, I actually haven't found how to trick the algorithm into giving my videos a lot of views. I know what works, right? So if I put a lot of work into like a big video project, I'm quite certain that this will get views. But usually I have to say I have zero idea if like a project gets big or not. For example, my last few e-bike videos I did, like I don't know, the last few I did like one e-bike video in the last year, but the last e-bike video, for example, didn't get as many views as my usual e-bike videos did previously in the first like half year or something, and then all of a sudden it just blew up, and I seriously have no idea why. Some of the videos take like, I don't know, months before they blow up. I actually talked about this with a friend a few days ago, because like the amount of views I'm getting is not really tied to like the amount I upload, right? It's really random. It feels really random, at least. I know that if I would upload more, I would definitely get a lot bigger on YouTube, but yeah, there's a lot of things in between YouTube, and I also want to, get things done. Actually, want to learn how to engineer one day and not just do YouTube videos, even though that's a lot of fun, right? It's the thing I started with, and I really enjoy it. Yeah, it's like an aluminium extrusion. That's true. Yeah, that's a better term for it. Right. So these are the rails. So what I did is basically I took measurements, 3 in total. Let's do this in red. So, oh my God, this is so fine. Let's do this again. This is basically this measurement right here is what I took. Then this measurement right here, and the last one is 2 down here, right? So these are the 3 measurements I took, and I put them into Fusion 360. And this is what we came out with. This is like a little box. So you can imagine just like the bottom of the electric scooter, right? Or this could also be the bottom, but who cares, right? And so what I try to figure out is how many cells can I actually put in there, right? Do I want to put a BMS in there? What do I want to do with the space I have in here? So I actually modeled out I didn't model out, right? It's just a box, but I created a little box in the same size as a normal 12S 60 amps, 12S 60 amps BMS. So I modeled that out, and I realized that the size was quite huge actually, and there was almost no space in there, right? If I put this battery pack somewhere in here, let's move it actually. This takes up a lot of space, like, yeah. So I would have to cut out like 2 pairs of cells, right? Yeah. I found that, let me pull up one of my battery management systems. One second. So these would be like 2 different. So these would be like 2 different BMS, right? And that's how they look. And they are quite huge. So this one is a 14S BMS. This is a 10S BMS. Let me think. This one, no, this is like just a plain one. This is like a stupid BMS, I would call it. It can only do like the basic things like balance out the cells when they get too high, and I don't know, things like that. This one is a smart BMS, so you can connect your Bluetooth right there to this header. These are obviously the 14 pins. Then there's also a temperature sensor in here somewhere tucked. I don't know. Yeah, this one here. Just the temperature probe against my face. It's better visible. Yeah, so this is obviously what I want. I want a smart BMS in there. I don't want no monitoring of the cells. I want to see if the cells actually get too high or too low of a voltage. So I see. If you look at this BMS right here, this is 14.7 millimeters in height, right? Let's see actually what we had here in mind. We had 20 millimeters, right? Why did I go bigger than this? Let's actually model out a same size BMS as this one. That was not the corner. Was right. That's 108 and 65. 108, 65, 8, 65. And let's extrude this by 15, right? Oh god. I did the wrong thing. We need a new body for that. Alright. So now we have this one. I don't know what this was. It was some weird modeling. It's the 14S. Also 60 amp version, okay. Let's say this was inside the battery somewhere. This would also take like a lot of space, right? This is not, yeah. I mean, this would like one BMS would take up the same amount of space as 6 battery cells. So I don't know, kind of a difficult decision. Should we put in a BMS or not? I would be leaning more towards putting in no BMS at all, and then doing all the battery management from outside. So basically, you connect like a no, not like this. Let me actually pull up. So you would make like a battery pack that kind of functions like this one, not looks, but like from the function point. You have like a 6S pin and you have a XT60 connector, and then you connect it up to one of these hobby chargers, right? And you just plug it in here, plug in the balance connector and the power leads, obviously, and then you can just set whatever voltage, whatever things you have, like profiles saved on here and things like that. This makes it really easy. This is obviously a little bit more hassle, right? It's like plugging in 2 things, not just one. And in this case, we can only make 6S batteries, right? So we want 12S in the whole scooter. So we would need to like charge them separately, or I don't know, use another. I have actually 2 of these laying around, so it's practically it's plugging in 4 things now instead of just 1, which is, you know, annoying. And you also have to like press buttons every time you want to start charging, right? But I think it makes more sense in this case, even though it's really not practical, because like the scooter, I'm not going to give this to anybody. I'm just going to use it for myself probably. Or somebody who, you know, has some idea of technical stuff and how technical stuff works. So yeah. 40,000? No, just 4,000. Okay. Job 91, yeah, that's a lot of kilometers. I actually have like, I don't know, I haven't looked at it in a long time. I haven't looked at it in a long time, but I have like, I don't know, 3,000 kilometers now on my e-bike, which is also quite a lot. Yeah, it's so much fun. Honestly, like especially now it's like 20, 25 degrees outside sometimes. So amazing weather. Degrees Celsius, obviously, but amazing weather. So it's a lot of fun riding around with my e-bike, and even though it's, you know, COVID and stuff like that, I'm still like, I don't know, going to the skate park and doing other stuff, and yeah, using it a lot more than I expected. With a legal German electric system. So upgrading a e-bike with a legal system, like that's actually a difficult task, right? The main issue, I think, is you probably won't get any parts that are kind of like classified as legal, because they all need like a ABE, Allgemeine Betriebserlaubnis. Let me actually show you what I'm talking about. All right. Actually, I want to. Okay, perfect. It's live here. Okay. You need like a yeah, something like this. I don't know if this is true for anything, but I heard that this is an issue if you want to build your own e-bike in Germany, even though, you know, it would be like only getting up to 25 kilometers an hour, things like that. This could still screw you over, so I wouldn't. I don't know. You can't. You like honestly don't even think about building a legal e-bike in Germany. It's not possible. Build something that is fun. Even if you want, build something that goes only 25 kilometers an hour, but you can always get sued for stuff. You can always get screwed up. Like German laws are so complex. There's always 10,000 things you could do wrong, right? So it's not like you can just build something legal, like a legal e-bike yourself in Germany. It's really complicated. I tried to get my e-bike legalized a few years ago and spent a lot of time on it, and it's not worth it. You need like TÜV, and you need like, I don't know, all these kinds of papers filled out, and spend a lot of money and time. Like, it's a headache. I never get stopped by police anyway, so who the hell cares? All right. No, not an e-bike battery, it's a scooter battery. Yeah, I think it would be so useful in Germany if like laws were more simple and you could just do stuff and not be worried about, I don't know, breaking every rule in the goddamn law. It's really annoying. All right, let's continue with this thing. So as I said, putting in a BMS like that takes up a lot of space. It's like 6 cells at least, probably even more than that. So we should do balancing from the outside with one of these, you know, way simpler, way easier. This, by the way, the Toolkit RC it's called. I don't know if I can get this into focus. No, autofocus is quite shitty on my phone actually. I don't know why it's not focusing. It's great, by the way. Toolkit RC, really cheap 6S charger. Used it a lot. It has some bugs actually. Mine doesn't work quite well, but I used some others and they worked well, so I don't know. It's cheap, but it works only half the time. So yeah, let's keep the BMS out. Not something I want to put in. And let's decide on how many cells. So another issue is we don't have that much space on top and on the bottom. What I already planned in is like a little bit of tolerance, right? This is, let me actually open this one up. This is a diameter of 18.8 millimeters, which I think this is probably on the like the highest end of tolerances. Let's actually look at the data sheet. Let's say we take some 18650 VTC6 or something. The sheet. Let's see what is their tolerance. So they say 18.5, and I actually went above that, so yeah, we should be good. Also, when you 3D print, like the casing and everything, even the battery holders, everything will be 3D printed in the end. So if you imagine like a 3D printer printing stuff on the build plate, it actually when it's extruding, everything gets actually pushed out by 0.1 millimeters more than it should. So all your models, basically all the walls you print, are actually 0.1 millimeters bigger in the X and Y direction than they should be. So that's something you should always keep in mind with 3D printing. And obviously in this case, it's 0.1 millimeter from this side and 0.1 millimeter from this side. And then there's in total now, let's say we actually get like the worst cell with this rating, 18.5 millimeters, right? And then we have like the worst case scenario where it's like 0.1 millimeters of 3D printing access from both sides. Now we're left with 0.1 millimeter of clearance. So yeah, that's like the tightest you should probably go, actually. Right. Let's actually measure that out. Like I'm a little bit scared that I do stuff wrong. Couldn't find 18650 that quickly. This should be one. Yeah. This is the Samsung 30Q cells. This is the one I also use in like my e-bike and my e-board. They are very old, actually, don't use them. I think there are better ones out there by now. Should be at least, I don't know. So yeah, let's actually measure this. So yeah, this goes up to 18.545, something like that. So this also gets quite high from the comes to tolerances. It's far above 18 millimeters, right? But that's also like due to the plastic wrapping. Like when they design the cells, they obviously can't calculate how big the plastic's going to be, right? So that's to be expected. But that's okay. That should be enough. So that should work. Why don't I take 21700 cells? Because they are shitty. There are no good 21700 cells out there. Like, I'm not even kidding. Let's actually look this up, right? This is my default cell supplier. If you know like a better cell supplier, let me know, because I'm always on the lookout for them. So let's go to Germany. 21700 right here. So you mentioned like the 40T and the 30T, right? I think the 30T is like a terrible battery. It's like high current one, right? I don't even find it here. But let's take actually the 40T one, right? It's like the higher capacity. So what we currently have on like the 18650 is like 3.1 amp hours, something like that, times 3.6 volts. That leaves you with 11.16 watt hours. Now this one comes out with Also 3.6, yeah, 3.6 times 4 amp hours. So that's yeah, that's 14%. What am I saying? Divide that like this one. So that's 29% more capacity, right? And if you now look at the size of the battery, this is 21. This 21 times 7 divided by 1.8 times 6.5, and I did something wrong. Let me see. Oh yeah, I did that thing wrong. All right. So these are 25% bigger in size. Did I calculate that right? Let me check for a second. Oh, it's actually squared, right? Let me actually do the full formula, because I thought I could like short out stuff in my head, but that doesn't work. So it's 21,700 squared, obviously. And this also should be squared. I hope this is not too small to see. Okay, now we get into better territory. Okay, that's what I wanted to say. So you have 46% bigger size. So these are 46% bigger than the old ones, but they only have right here 29% bigger capacity. So that's terrible. Yeah, there's nothing good about them. Also the internal resistance I've seen is quite high. So let's actually check internal resistance. Data sheet. Did they take like internal resistance test? That's a inaccurate like that. They measured internal resistance in ohms, so that's very useless. Can we get a internal resistance somewhere? This is just a packaging thing. No, there will be no internal resistance on here. Come on. Oh, right here it is. Impedance. Okay, we can also go with the AC impedance, right? So this is the AC impedance of the, let me remind you, 46% bigger cell. Let's compare that to the Samsung 18650 30Q. Let's compare it to this one, right? This one has the internal AC impedance of where the hell is it? Right here. Come on. All right. Internal impedance 26 milliohms. This one is 12 milliohms. Oh, that's actually like good thing, right? That's actually not too terrible. At 1 kilohertz. Okay, they also measure at 1 kilohertz. So, I mean that's like a benefit. That's the only benefit I can see right now, is that they have better impedance. So yeah, that's currently the decision why I never use 21700, because they are very bad at energy density actually. Maybe in the future, I don't know if, but I don't think they will last any longer. Like the whole industry is already over the, like they don't use 18650 anymore. They don't use 21700 in like the large scale vehicles anymore, and they won't be using them in the future, I think. The whole industry moves towards like bigger and bigger cells. That's like the whole point. you want to make your cell yeah, more useful for electric cars, for example, and not just for e-bikes. So that's very important. I thought nominal voltage was 3.7 on lithium ion. That's actually an interesting point. Sometimes it is. It depends on how the cell is made. So what you have usually is like, actually on this side of yeah. So you basically you have this graph, right? You discharge the cell and measure this graph. And what you want to do now is basically build the integral of this whole graph, and you will come out like with the surface area underneath this curve, right? And when you have the surface area underneath this curve, you can draw a line, basically build like a square, and the square will usually go around like 3.6 volts. Like if you take the pink line, for example, it will be somewhere around here, like 3.6 volts go from here to here, and that will be like the same amount as like the, let me show you this a little bit more graphically. New save. All right. So if you build like the integral of this, and from the pink line, let's actually do also pink or red, something like this. Then you basically build out this. You can build the surface area will be the same as this, something like that. But you can already see like there's obviously something like here, for example, they measure with different kinds of currents, right? So now all of a sudden you're getting different kinds of energies. Also, they stop at 2.5 volts. Not everybody stops charging at 2.5 volts. So there's a lot of like variance in here, and you can basically, depending on how early you start with your battery, how hot, how cold it is, how much current you're drawing, and things like that, you can basically manipulate the voltage reading, the integral voltage reading. You can manipulate that down and up however you want. So so especially like smartphone cells, they use like they charge up to 4.4 volts actually, and don't go down as far. So they start up like very high here, and then draw down to like 3 point somewhere volts, and now all of a sudden you're left with like integral that goes around 3.8 volts or something. So smartphone cells, you will usually see like a rating of 3.85 volts, for example, right? So the rating, this is really stupid. So usually they say like 3.6 volts on here, but just to apply to the standard that everybody applies to. And as I said, this could be like in reality that like no cell has exactly 3.6 volts nominal voltage. Like it's calculated from the integral, and it's very different depending on every scenario of every cells, and you can manipulate it around however you want in theory. But everybody just kind of applied about that the 18650s and 21700s also, they always use 3.6 volts, and that's just the standard right now. They will probably change it in the future as soon as you like find new chemical things to combine, and all of a sudden the voltage shoots up. So yeah. Can I recommend the 100mm off-road wheels? They're okay. Like I broke some chunks of them, especially on the rear where there's a lot of torque, and the motor sometimes hits like a hard curb or something. Like small urethane chunks were falling out of the wheel, so the wheel is like a little bit smaller now. But other than that, yeah, I think I can recommend the 100mm wheels I have on my electric skateboard. Let me show you. MBS, all these are what I'm talking about. These ones. These are the wheels I currently have on my electric longboard. What is annoying about them, like don't ride them in the rain. They are super dangerous when you ride them in the rain. They have like the smallest surface area you can possibly imagine. Like you're literally riding on like 1 or 2 centimeters of surface area right here, maybe even less. And only once they're ridden down a bit more, they're getting more and more surface area. Some people just do burnouts until they are flat, basically. But yeah, as I said, they are super terrible in rain. So as soon as the streets are wet, like, don't go outside. Like, generally, just don't ride your electric skateboards. The urethane wheels, they are so slippery, they are so hard, and they just slide over everything that's wet. Yeah, no fun. Hi guys. Ooh, thanks for everybody's tuning in. Well, there's actually a lot of people right now. You'd like to go off grid. Well, that's great. Like, I mean, with Starlink and everything that's currently happening, you can do a lot of things that weren't previously possible, right? So in theory, you could also go off grid right now and still be like connected to the rest of the world and actually like do stuff. So that's cool. So yeah. So what I want to do right now is basically figure out. Let's fuse some of these bodies together, right? Let's make like one battery block. Oh yeah, super weirdly. Okay, this one, and this. No. That's the wrong one. No. No, also not. This one, okay. Let's fuse them together and create components from bodies. Right. Oh god, no, that was stupid. I named them so terribly. So, can we actually combine them? I don't know. Does that work? No, we still have like one battery. What is even going on? I don't understand. Can I combine them? Or not? I don't understand. So I can't really combine them. Yeah, we're gonna leave them separate. Let's just move them to a group. Oh, should maybe do the group before that. Create new group. Cells. Boom. Oh, that didn't work. Okay. Let's make a new group and call that like the rest of the system. MISC, something like that. Let's move everything to that group. So what I want to do is like build like a system around the cells, a little structure. So let's think of it like we want to build a battery, right? So I think the easiest way to build this battery is like already have like this form ready with all the possibilities, like the places for the cells, and just push in the cells one by one. But there's not enough space to like have anything between these cells. So I think the next best solution would be to like at least have like an outer ring around all the cells, and you put in all the cells, and you already have like the structure holding everything together. Also, like wiring has to be done. So let's actually check how much space we have. So definitely all the wiring, right, from the left and right. You can't wire it on top. There's zero space, because as soon as I put some walls on here, like they need to be at least like 1 millimeter thick, so there's zero space there. And also, let me check how much space do we like really have? So I wrote down 55 millimeters, but come to think of it, like if the plates are in there, this could be even less. Are those bullets? Yep, I'm building a big gun. That's my plan. How did I get Fusion 360? Just download it. It's look up right here. It's the education license. I don't know if you can see that. I don't know if the quality is good enough. But yeah, you can get it for free. Just go Google Fusion 360 education license. Just download it. It's a lot of fun to learn. Like it's the most like fun CAD system I know. Like honestly, like compared to SolidWorks or even CATIA, like I used CATIA before and things like that for like different jobs I had, and oof, that's like oof. These are like, I mean, just look at the interface. Let's look at CATIA for example. I mean, just look at the interface, right? That was actually just the modern version. CATIA V5, that's like the most commonly used like in industrial applications. I see. I want to have like a thing window. Yeah, right here. That's how it looks. Yeah, that's exactly like just look at the like the menu bars and everything. That's how other CAD systems look like. So Fusion 360 just very clean, simple, and has like really nice interface actually. I love it. It's honestly like the best CAD system I know. Yeah, so I want to take a measurement, right? I want to take a measurement of how much space we actually have. That would be really, really useful. Yeah, let's actually do that. I'm going to take quick measurements of how much space we actually have left in there, and going to be back in just a second. So yeah, measured it out. There's definitely enough space in there. So we can write that down, right? We should make like a notepad plus. Let's see. So things we know, like it's around 75 millimeters actually of depth. Oops. I'm writing like an idiot. Holy shit. Also, so we have like even more clearance than we actually have planned in. Like it's 55 millimeters currently. We actually have some more. Also, we have like three parts, three pieces of these metal things laying around. So we have like three mounting points basically. Three mounting points. And let me think what else is important. Yeah, I think that's it already. So this is definitely possible. That's already good to know. So that was what was like my biggest concern if we have like we run into like issues with like the clearance, if actually these amount of batteries will fit on top of each other, but they will do so. That's good. Some of you are spamming in the chat. I don't get why. All right. All right. Yeah, let's actually do this. Let's go with the flow and just design a framework for the whole battery. So something that goes around this. And let's continue from there. So I'm going to make a sketch right now. I actually want to make the sketch into origin if possible. So yeah, we have it's always annoying if you set a reference point that's like so far away actually. So getting the reference point from like the origin is always the best idea in my opinion, because when you set like the reference point, if you do like a sketch on top of like things you already sketched out and extruded, as soon as you move them, also your future projects, but I don't rely on them, right? So these are only for like quick measurements and to check if everything fits, and I won't need them later on. And if I now do the sketch, like I can show you like the difference I'm talking about. You can either like do a sketch on top of these, right? I can click on them, and now my sketch is basically bound to this item, to the bottom of the cell. But since I probably will, I don't know, remove them later on or something, or maybe change them later on, yeah, you don't want to be bound to like a quick SketchUp thing that you did. So it's always good to like go back to the reference, always go back to like the starting point where you actually started from. Yeah, if it's just something that's not going to be permanently inside the part later on. So what we start with is basically we're going to be projecting all these different components. So I don't know why dragging doesn't work. Usually it works. All right, let's select them one by one. No need for that. I select so many points, it's incredible. All right. So we selected them all, and we create basically some projections of these. So now we can basically hide these right now, hide the cells, and we're left with this overview of this imprint of all the cells. I don't know why the hell this one guy is spamming. I'm sorry. You have to go. You're spamming too much. I mean, you can write as many messages as you want. Like, I'm not mad at that. Like, do whatever you want, but like, don't be annoying. Like, I don't care if you like chat to each other and stuff like that. Like, honestly, you can write as much as you want, but I just don't want anybody like writing stupid shit all this time. Heilbronn is a very nice city. Press X to doubt. I don't know. I think it's okay right now, but a few years ago it looked terrible, and currently it's only looking better because one rich guy is pouring in a lot of money. If you live here, you already know the rich guy who is pouring in a lot of money into the city and why it looks better now. So we want to create like an outer bounds of this thing maybe. So I think the first step is going to be, first up I want to make this just a rough sketch. So we're going to hide this and press X. So now we have like a hidden kind of thing. And we're going to make this tangent to like different objects. For example, this one right here. We'll make this tangent to this one, make this tangent to this one, and this one tangent to obviously this one. So we have like a outer boundary of this whole structure. Then we can do like an offset. So this is basically just pulling in like creating like a line around whatever you're choosing. You can also do this with all kinds of weird objects. So I could theory like do it with I don't know, it's with a circle obviously. Could like select the circle and create an offset of the circle. Yeah, in this case we want to do one of this. So the height is currently 51.4 millimeters. So we checked earlier, right? There was like in total 57, but we want some clearance, right? So I think 1 millimeter of clearance would be already too tight in my opinion. So I'd go with 55. So now we have 55 millimeters of clearance, and we currently are already 51.4 millimeters thick. So let's subtract that, and we are left with 3.6 millimeters of space. And then let's actually Obviously divide it by 2 because you need like space on top and on the bottom. Oh, I'm thinking wrong. Hold up. Am I doing this? No, actually it would work. I think it would work. 1.8 millimeters. So I think we're going just with that. It's 1.8 millimeters on the bottom and on the top. So we're going to do an offset. This is going to be 1.8 millimeters, right? Yeah. Let me think. Should we make this smaller? I mean, we could in theory do like, but this would also weaken the structure. I actually want to do like put in more clearance here, right? Like this would be nicer to have this a little bit bigger, maybe. I don't know. To have more clearance in there in case the cells don't fit. Like I'm always worried about like doing things too tight and then stuff not fitting in because that's like the most annoying part. Do you have cell fires in the particular? Do you have cells? What? Do you have to have cells fire in particular order? I don't know what you're talking about, but are you talking about like how they are connected to each other? Because I don't know, it doesn't really matter how you connect them to each other. You obviously want like in this case, I want to make a 6S battery, so we will connect 6 batteries in series and 3 in parallel. So it's going to be like 1, 2, 3. These are all in parallel to each other, and then the negative side or the positive side of this one will be connected to the negative side of this cell, and so on and so forth. So yeah, that's actually, so we have the outer parameter already. One thing that's really annoying to me right now is they don't touch each other apparently. Like there's obviously a gap in there because when I select this, I also get this one selected. So what we don't want to do next is probably, can we do like, yeah, okay, so it should probably even work. So there's also no connection in here. Let me think how we can fill these gaps in. I think the easiest solution would be like to do offsets of each one of these and do them a little bit bigger. I think that would be like the easy fix of this. So yeah, let's do this. 0.1 maybe, something like that. Is that enough? 0.2. Let's go with 0.2. Come on, that sounds nice. Oh, not a repeat offset. Oh no, I did something wrong. Let's try this again. 0.1. That's not the correct one. 0.2. Okay. Now we got it. Okay. Hey, that's annoying. Like, how do I select the full circle? It's not really possible. All right. Can I do this? Ah, that actually works too, right? So let's actually do this in like a macro kind of thing. I don't know if this will work, but let's try. Oh God. I did the wrong thing. All right. Oh my God. Oh my God. I think this doesn't work. Try again. So annoying. No, it doesn't work. It definitely doesn't work. You can't select all these models at the same time. I think it's only possible with these half things right here. So let's do an offset of them. 0.1, 0.2. Okay. Is this possible? No, that's also not possible. It's quite interesting. Sometimes you can like queue together offsets, but in this case it doesn't work. It wants to do them one by one. Uh, oh, that's can't select that one. 0.2. So yeah, basically now we're creating like the outer shell of all these things. So my plan currently is I want to have like a kind of small box already. You can push in all the cells from top and then weld them all together. So I think that would be like the easiest way to build these batteries. These are probably because there's like no real space in there. Maybe I can get like a screw type of. I mean, we could in theory like do screws here, here, there, and there. That would be possible. So you can screw the whole battery pack together in the end, and it doesn't have to be glued. But I don't think that will work. At the okay, you said something. Look at the Molicel P4A. Holy shit! Let's look at this. I think that's a scam. Like, who the hell is Molicel? Never heard of the company. Like, honestly, who the hell is that? Do they actually make cells, or are they just the problem is always with these companies, a lot of them resell batteries, but it actually looks like they actually do stuff, apparently, according to their very cool website. So these actually look like they actually do stuff, right? It's not just somebody reselling batteries. For example, I don't know, Fire Trust or Trust Fire. I don't know. No, Trust Fire. I think Trust Fire. Yeah, these batteries, like, they are all scam. Like every battery you will find on this side is a scam. They're just here. Look at this. You can go like PCP. I don't know. Like, these are all scams. None of these are real. They all have fake capacities, and also Ultra Fire. These are also like very, very, like, none of these batteries are legit. Like, they sell some stupid, crazy high. They claim like their battery has like 10 amp hours or something. In reality, it has like 2 amp hours. Also, like, what's another company to avoid? I don't know. There's a lot of them. Like, that's the problem. But yeah, actually looks good. Like the cell, honestly. If there's a good supplier of them, because like, the problem always is like, is there a good supplier of these? Because if I can only buy like, I don't know, one for €5 or something, that's not worth it, right? They're like triple the price of anything else. Do they sell them on here? Yeah, they actually do. €5 is still quite a lot. But they look nice. I mean, honestly. Do they have like a nice data sheet maybe? Let's look at these. Oh, that's good. Like 10 milliohms, that's really nice. That's actually like the honestly, that's like already worth buying them if you have like a very high power application. Like, honestly, they make good cells apparently. 230 watt-hours per kilogram. I don't know why that's so low. Is the weight so high, or I don't get it. Like, that's usually a little bit. I think there are some 18650s that are way above this, but I don't know for sure. Yeah, but honestly, like, thanks for recommending that cell. That's a nice cell actually. And apparently they actually produce their own cells and not just, yeah. All right. I think we have, yes, we have it. No, not fully. Okay, these still need offsets. So 0.2, 0.2, something like that. Right, now you can see we can select like the outside of this whole thing. That's good. I also would like to, I don't know, see if we can pull this off somehow. I don't think it's that easy. I wanted to let's hide all the inner. So what I usually want to do is like have like a kind of clean sketch, so there's not too much lines in there, because that will usually mess up all your drawings later on if you have like really bad. So this one looks good. Yeah, all right, we have it. So what I would do right now is basically extrude this. Yeah, we should just extrude it by, I don't know. We can do a little bit more than the cells height, right? So, because we want to weld on top, but also like I want to mount on stuff on there. So, let's decide how we should. Okay, I got an idea how I can do this. So let's do actually 6.5 right now. But let's actually give this stuff some space. Pull in the space. All right. So we still got like a lot of space left here. So there's still 8 millimeters left, right? So that's good. We should round off like the corners maybe. But I don't want to do this in Sketch actually. That's stupid. Let's actually do a round. No, what's it called? Concave? No. I don't know what it's called. It's called fillet. That's a stupid name. All right. Let's do a fillet on all of these little things right here. So it's actually printable. 1 millimeter. Let's actually do 2. Yeah, I think that looks nice. Something like that. Right. So now you could imagine like putting in all the cells, and then you can easily weld them in there. It's like a already nice placeholder for the whole project. We did a group by in the Eastgate group. Yeah, I think when you buy them in bulk, usually like cells can get pretty cheap especially if you find them on like AliExpress or something. So yeah. All right. Yeah. So we can now already plan out like we get nickel strips on top, right? So there will be, let's see, let's put in the cells. So usually you have like a width of around 1 centimeter of nickel strip on here. Let's do a sketch we'll delete later on, right? Let's imagine we have like here, let's project this. Oh my god, project this one. Done, okay. Now we want to create like a box, rectangle with the center. So something like this. This would be 10 times 10. Let's go something like that. So that would be like your average nickel strip, right? And this nickel strip now could be pulled through like till here. Yeah, it would be like going over these little bumps. So what I want to do right now is basically create like a little bit of more space around like the top thing, because we will also need to solder on like the balance tabs and stuff like that, or yeah, later on. So that would be for me like the next logical step. So it's actually take one step back and delete this sketch right here. Let's hide the cells. So what I want to do right now is see where the origin is. Okay, origin is on this side. Let's do another sketch on top. And now we're actually, this is now different because now we're actually referencing this object. So instead of doing a sketch on top of the origin, we're now doing the sketch on top of the object itself, because we obviously want to relate to it. We obviously want to extrude some stuff on this object. So this makes now way more sense. Just let me see. We got this already project. Now this is stupid. We need an offset. This one. And this offset, can I give it like no size? Is that possible? I don't think that's possible. I want to be fitted on here. Let me check if I can do this. Let's remove the size. Yeah, it actually works. Yeah, okay, that's cool. All right, so we can make this. We can. Oh, actually, that's bad. Nah, that's not good. I want to have it like on the. I want to see where like the largest, where it pokes out the most, and fit it to that. And I think that's probably going to be somewhere around here. I don't know. Let's check. Yeah, it's hard to check, but it should be something like that. Okay. So let's just assume this is like the biggest furthest out from here. We're going to fit this to this. That's not possible. All right. And let's do this to. No, that's also not possible. Okay, and then just fix the distance. Yeah, that's good, I think. 0.6, yeah, sounds about right. And then let's extrude from here. So let's think of how much space do we actually need. Like, let's say we weld on top, and we will do other things. We need to solder on top, we need to weld on top, we need like space for the wiring. We have like enough space on here, so we can, I don't know, we can make it however thick we want, because in total we are still pretty good shape right here. So we should do like, I don't know, a few millimeters, maybe like 4 millimeters. Will wires fit through that, right? How thick are these wires usually? So they're 1.6 millimeters. And then when you weld and solder on top, this could be like 2 millimeters extra. So I would say we're probably for spot welding the nickel strips on here, and then soldering the wires on here, we would probably need like more than that, actually, like 5 millimeters maybe. It's going to be a pretty tight project, I already know that for a fact. Yeah, so we got like 9.3 millimeters left. So I think we should do like 4 millimeters, something like that. Yeah. Yeah, let's do 4 millimeters. Yeah, that should be plenty. I think that would be enough. It's going to be interesting to actually solder. Like, let me check how thick are these wires, for example. So on a normal battery pack, yeah, these wires are already like 4 millimeters thick. So this is going to be quite difficult to fit like the wiring and the nickel and everything underneath here in just 4 millimeters of thickness. That's not a lot of thickness, I'm just saying. So you want to find the sketch window. So you just press S. You mean this one, this design shortcut. Just press S and there you go. And you just type in whatever you're searching for. Like, I don't know, extrude. So what I miss about this is they should use tags. So if I use like put, you should also like put is another word for a lot of CAD programs use for extrude. So they just should show up like extrude. Generally, like searches are pretty dumb. Like usually if you search stuff, there are no tags attached to like any of the search terms. So what I mean by that is like, you know, I can type extrude, right? This is the function I want. But a lot of CAD programs, you know, call it put. Type in put, it should also show up in my opinion, but it doesn't because they never used any like kind of tags or anything like that, any quick search words. Yeah, so that is that. There's so little space in here. This is going to be such a difficult build actually, like to come think of it right now. But also if I would imagine like 21700 cells in here, this would be like even more difficult. Like honestly, this would be like the hardest build ever. Like I could barely fit any cells in here. So I'm quite glad I'm currently using these. So let's use this and go the other way. We want obviously minus 65 and then also minus 4, right? And then we want to show this body and join that. Yeah, looks nice. All right. So we have like body of the cell pack already. Still, I'm wondering how I can close this up. This is going to be so difficult. Let's think of that for a second, actually, right? Like, let's imagine we have all these cells in here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And the last one is like 1, 2, 3, 4, 5. So in theory, I want to have like positive and negative terminals on both these ends. That would be like the easiest way to solve this. Then you would have like 3. Then on the other side, you would have like, I don't know, 3. And there's no 3 on this side, right? Let's actually do something like that. Cells. I don't draw that out for a second because I think otherwise we'll have a problem later on. Right. So let's imagine we are, let's say, positive terminals. So coming out this one, way too thin. This one is going to be plus, right? And from down here, we're going to take up minus. Oh, this is stupid. Let's make plus red. I like I don't know, make it bluish. I just want to have black because black is like barely visible. Also, bluish is also not visible here. this one. All right. So let's imagine what should we connect, right? So we should connect like 1, 2. This one? No, this doesn't make sense. 3. Maybe like this, right? And then on the other side, the negative connection would be these 3, obviously, right? And the next 3 should be probably like this, actually. Right? And then it's going this side, right? It's going to be 1, 2, 3, maybe. And then on the positive side, we're going to connect these 2. Now we need 3 new cells, so we're going to take like this, maybe. And then we're back on top. We have these connected to each other. And we're going to take up these 3 in the back right here, maybe. See, the problem is I can't do like, I don't know, I don't want to have minus on the back and positive on the front. This would be obviously the easiest. So you would just connect 3, 3, 3 to each other. Would be like the easiest solution right here. But I think that would be quite annoying actually, because the terminals now would end on this side. Now you need to run a wire all the way to the front again. There's like so little space in here. I want to make it like as space efficient as possible and not risk like having anything. I also have a link here, for example, how you should make a battery pack. Links don't show up in the chat. Okay, do something like this. Let's say if you want to post in a link, I would do it like this. Like, can I do the font bigger? No, that's not possible. All right. I hate this editor. Let's actually do this Visual Studio Code. That's way better. Like this. Okay. Can I do this? Yeah, okay, that's perfect. Okay. If you want to post in a link, like post it like this, link dot and then whatever com, like this. Just replace the dot with anything, and it should work. So I can copy it out and edit it, because I think it's basically YouTube does that itself. I can't really change anything about you guys not being able to put in any links. So just yeah, put in the link and replace the dot with a dot. Yeah, but also like the layout I'm currently drawing, like this is shitty. Like honestly, this is a terrible layout. I hate this. Yeah, this is stupid. So with three new cells, right, and it would be these 3 cells. It would be connected to like this and this, something like that. And then 1, 2, 3. So these are in the front. So we're front. These are back. These are front. These are back. So now we're getting back to the front usually, I think. I don't know. Yeah, I have no idea currently how I want to do this. So I think the better solution would probably be like this is like the plus terminal, and then go like 1, 2, 3, connect these to each other. Then on the back of them, that's just black. connect these to each other. And then we're back on the front, right? It's like plus, plus, and now connecting these to each other. And now you're searching for the 3 next negative ones. Something like that. And then on the back, this is going to be connected to these ones. 1, 2, yeah, let's go with this one, 3. And then we're going to be back on top. These two connected, and then it's 1, 2, 3. What the hell am I calculating right now? That's... No, there's no good layout. Like, honestly, there's... I should probably just connect them like this to each other. It would be like the easy way out, and then just run a wire from the back all the way to the front. Ah. Great, I'm getting a call. Hold on 1 second. All right. By the way, the reason I'm switching off my camera is because currently I use my phone as my webcam because I don't have a decent webcam currently. So yeah, every time somebody calls me or something, I have to turn off my camera and then I can answer them. So yeah, I'm still pretty like, I don't know how to solve this very efficiently. So these 3 will be a pack, right? These 3. Negative, and then we're positive, so we're here, back here, negative. 1, 2, 3, like this. The connection would be between here and here. Connection would be on the back. Then from here on, negative, so these would be positive, right? Positive, positive, positive. Connected to each other, and the green one connects these. And then the last three ones would be right up here. I think that would be like, honestly, that would be like the okayest solution I could come up with right now. And then it's like minus terminal right here. I think this would be like, honestly, our setup. Yeah, so that's our plus terminal up right here. And you're wiring through these, so these are like the highest, these are like the 6S. So you write this down, 6S right here. And then on the back, you have like basically somewhere around here, you have like the 5S. And then it goes back to here, here it's 4S. Then somewhere around here, it's 3S. And then here it's 2S. These here. Then back here somewhere it's 1S. And when you come down here, it's 0S. I don't know. But it's like the minus terminal. I hope that this is kind of understandable. It's kind of messy, but I think this would be the best solution. So instead of like using this is not going to be like a very intensely high current battery. So I think this would be okay. And this would be like the easy solution for this issue. I'll go with this one right here. So yeah. Very ugly drawing. I'm sorry if this was not understandable. It was a terrible drawing, I know, but I want to adjust the angle a bit. Something like that. All right. Let's actually make my camera a little bit bigger. Looks good. All right, next step. Next step would be, so we have this body around the cells. This should fit inside the space we have. Yeah, will barely fit. This will allow for all the connections, all the wirings to run through them. Yeah, I think that's it from this point of view. So we got some space in front of this and on the side. So now we're basically constrained, right? If we look at our total space from top to bottom, right, it's completely filled out right now. There's like, we can't do anything about this. From this side to this side, we're obviously, that's a line, that's probably, you can see we if you move this up here, there's no space in here. So also the clearance on this side is pretty much gone. We still need to design like a cover for this, but this could be really thin. This could be like 0.5 millimeters thick of like a cap on side there. So yeah. Hast du Erfahrung mit Fahrzeugen? Yeah. No, I don't have any experience with vehicles getting driven by portable drills. That's not really my area of interest, honestly. All right, so I think this would be like an easy solution, right? So now we got like the wires coming out. Let's decide on which side they should come out. I think this would be like the better side. So what I would do is I would just pull out the nickel strips, and the nickel strips, in my opinion, should just run down on this side. It should come out and go like down here, so we can solder stuff to it on this side. That would be like my kind of idea, right? So let's remove the space again. Yeah, all right. Let's see how thick are usually my nickel strips that I use. So these are the usual nickel strips I will use. 10 millimeters, I think the thickest ones. Maybe I'll use 50 millimeters are usually already too thick. Yeah, these are also 10 millimeters, so I'll use something like that, 10 millimeters probably. So we will need like 10 millimeters of clearance on this side when the nickel strips go down here. So let's design that. Let's do a project again. Project, not project. So yeah, something like that. And let's create some rectangles from the center of these. These can be like 10. Well, actually, let's make them a little bit bigger. We want to have some clearance, so let's make them 12 times 12, something like that. Right? And let's do the same thing right here again. 12 times 12. Oh God, what I'm thinking right now is maybe I can even mirror the whole battery, right? You could, in theory, just work on one half of it and just mirror the other half. But that's usually like a little bit annoying as soon as you, I don't know, want to make something on the plus side that you don't want to do on the minus side. So I don't know. But in theory, like when you have like a model that is like it looks symmetric. If you work on a symmetric model, you can in theory just slice it up in the middle, right? I would do like a slice in this direction and just work on one half. And then when I'm done, like I can mirror all the things to the other side, which makes it a little bit easier. Yeah. All right. So what I'm thinking right now is just using these. And let's use this too. And just cut through this. Actually, we don't need that much space to begin with, so let's keep it down a little bit. Let's say we need like 2 millimeters, something like that. Maybe a little bit more. I don't know. Let's go with 2 millimeters. Right, so these are like for our nickel strips. This would be a plus and minus terminal. Right. So now these fold down here. What we should definitely do is like design something that they don't flap around, because that's like the worst part. Nickel is really, you can easily bend it, right? But if it's like in a vehicle and it gets bent, it gets bent forwards and backwards like hundreds of times, eventually nickel is going to break. So we want to like kind of not do that. You know what I was really annoyed about earlier? I actually want to like, usually when I work on these CAD models, I listen to music in the background, like lo-fi kind of like techno or stuff like that. I don't know, whatever I feel like. But like it's really hard to actually find like music you can listen to while you live stream. That's super annoying. Like honestly, like usually I just really enjoy modeling stuff in CAD with some music in the background, but right now it's yeah not possible with the current copyright systems and things like that. But I mean, it's stupid. Like I'm not making money off this, so I don't know. In theory, I should be like allowed to do that, but it's not legal. Yeah, I can't just do live streams and play music in the background, because that would be like yeah. Let me actually get some water right now. We'll be back in a second. I never heard of synthwave. Sounds interesting. I hope you guys don't hear this. I don't know. Let's open Spotify up. Otherwise I will get synthwave. Oh, that's like vaporwave kind of thing. Okay. Yeah, I'll definitely listen to some of this stuff. Like I just pulled up this playlist right here. What the fuck? The first lead is Cornfield Chased by Hans Zimmer. Like that's I don't know, about synthwave. That's not synthwave. Yeah, sounds interesting. Like you can already see I didn't listen to this playlist ever, but like that's already kind of like my music taste when it comes to like I don't know, when I work on stuff I usually want to listen to like techno and I don't know, something upbeat or something. It's like I like the angle my camera is filming. Let's maybe change that a bit. I don't know, it looks just up my nose. Let's do some gums. Something like that. Oh my god, somebody tipped me money. Holy shit. That's like the first actual tip somebody ever gave me while live streaming. Thank you so much, Timmy. That's really nice of you. Vielen Dank, ne? Sehr nett, sehr nett. Yeah, so yeah, definitely synthwave would be something I would listen to. Let's actually, you know what? I'll add this playlist to. I heart this playlist right now, and I'll listen to it later. You know what I really enjoy when we're on talk of music already? I don't want to show my friends list here, but right here, these are like my favorite like chill and beat playlists, right? And I think like maybe while driving, honestly, this one is super cool. Retrowave Outrun. It's directly by Spotify. These has like such cool tunes on it. It's like not really 8-bit style music, but it's like these pumping I don't know, synthwave, whatever, electronic soundtracks. I really enjoy that. That playlist is amazing. All right, well, let's continue with our design. I want to get something done today. I promise I won't be chewing too loud. Some weird ASMR type live stream. I don't want to turn it into that. So, we got the gaps open for our nickel strips, right? But it's only positive and negative. We also want to have like balanced connectors running out. These are definitely going to be running out from both sides. So I got some balanced cables right here, right? These are like the typical cables you would use. So I would say, let's just take the measurement of them. So they will need like a, yeah, okay. They will need like a height of 0.4 millimeters, something like that. Because we're 3D printing this, it's definitely going to be like 2 millimeters or something. So we have enough clearance. And then it's going to be, I don't know, 14 millimeters. I mean, these are 40. Okay, this is for like 10S battery, so yeah, but actually keep it on the same width, so 14 millimeters times 2 millimeters. Let's actually sketch that in here too. So this is going to be running down in the middle. I want to have like a symmetric thing of this. Can I do this symmetrically? Let's try this. Do a line. Hide that line. Make this symmetrical from this line, this, and this point. Ah, okay, now it's... So yeah, now it's locked symmetrically. So that's good. Oh no, I didn't want to do that. What the hell is happening at the end? That was stupid. Okay. Okay, nice. Okay, so now we can create a rectangle with a center point on here. Holy shit. Danke, Tim. Timmy. Sehr nett von dir. Ja, ich kann später online lassen. Dann packe ich in eine Playlist. So, the stream, once it's done, I can do it, put it in like a playlist. But honestly, I think if you just want to learn some CAD design, like generally, just watch tutorials, because like that's a way faster way of learning this kind of stuff. Like that's at least how I learned it. Like there are so many good tutorials out there that explain stuff really quickly, and you can easily get a hold of it and you understand it like immediately. So I think there's like better ways than my live streaming content. But thank you so much for the donation. Really helps out a lot, actually. Like honestly, all this money goes directly into my projects. But you don't need to donate anymore. Like honestly, I'm just trying to make a live stream. I don't want to make any money by this. It's just me having fun with CAD. Yeah, we said 50 millimeters in height, right? Oh, that's a lot. Let's actually go lower with that. Let's actually calculate the exact amount, because I don't want to waste any space here. So the exact amount we would need is 1, 2, 3, 4, 5, 6, something like that. So it would be like 8 or 9 millimeters. Let's go with 9. So this is still a safe bet. We still have enough space, but yeah. So yeah, again, these are for like minus terminal, for example. This is the plus terminal, and here will be the balance connectors will be routed through this, right? Yeah. Yeah, let's go. Let's hide our sketches. So now we're here on the side of this thing. What I need to see right now is how much space we actually got left, right? So in total, this thing is 300 millimeters, right? So 300 millimeters minus like the side right here. This is minus 125.8. So we're currently sitting at 170 millimeters of clearance. But actually, to calculate the left space in this direction more effectively, we need to multiply this by 2, obviously. No, times 2. All right. So now we actually have 48 millimeters left, right? And since we got like 2 battery packs, that's like a weird bug I have from time to time. Okay. 2 battery packs, so it's only this amount of space left. And then on top of that, it's going to be quite tough actually. So how wide are these plates? Calculate them really quickly. These are 3 centimeters, so 30 millimeters wide right here. So that's tough. So we can barely fit one of these in here. So what I think I'll be doing is, since there's not much space in there, I'm probably going to be just with a saw cutting one of them down the line and then drilling new holes in here. So it's going to be like half the width or something. So we can easily fit these battery packs in there. So that's going to be like the main point of this battery pack, right? It's going to be, you can just pull it out of the scooter probably in the end. So that was at least my initial plan, right? I want to make like interchangeable batteries, a battery pack that you can just clip in there. I want to make like a latch mechanism. Let's look at a latch mechanism from the side. Actually, I want to save this almost. Can I open a new instance of Paint? Yeah. So I want to have like, let's say this is our battery, right? Just a finished battery pack. I wanted to have like a latch on this side, obviously. So it's like a little thing extrudes from this side. And that's going to be latching onto like this is going to be like the permanent rail here. Something like that. And the scooters, obviously, you know, having, oh my God, something like that. So on this side, it's this rail. On the other side, I want to have like a latching mechanism, so it looks something like this. And it has like a thing to pull from. And then it obviously latches inside here. I hope this is understandable. I hope this is not a too terrible of a description. So something like that. This is going to be there's like a very, very rudimentary and simple explanation of what I want to do. But I want to make like a battery that you can basically put in from the back here and then just latch on the front. It has like this big latch here. It's going to be obviously very wide and things like that. So yeah. And yeah, that's how the batteries should work in the end, I think. That was at least my initial plan. And then also I want to have like a fixed, I wanted to have at least that's why also my initial plan, have like a fixed connector system on here. So the connector is already down here. And this thing basically just plugs in here directly with, like, when you push it down, it automatically plugs in here. But the more I measure stuff out, the more I realize I either need to leave out like at least like a few cells and make this like a go down from currently we are at 12s times 3p, and we need to would in theory need to go down to two cells in parallel, but that would be like kind of a low capacity battery. That would be like not good. I would rather like plug in stuff by hand and have like a little bit not so clean wiring inside there instead of dealing with this kind of stupid stuff. Yeah. So I think the current decision probably should be, I don't know, leave this automatically plug-in mechanism out and just focus on, yeah, these rails, and that stuff can just click in there. I think that would be more useful. Let's try that out. Oh, that's too bright. All right. So yeah, the clearance is not too big. So like I said, we currently have This is the current amount we have on when it comes to clearance. It's only, so I think we shouldn't go above like 1 centimeter of extra space on here. So everything from the balance connectors, how the balance connector terminates, and how everything else connects, there shouldn't be more than like 1 centimeter of extra space required for that. Let me think how we can start that off. I think we'll make like an open box in this direction, right? Yeah, I think that would be like the easiest way. Let's do that. Create a sketch on this side. I don't want to make the walls too thick, but I think 2 millimeters would be good. Yep, that's perfect in line with this one. So something like that. Think of this. Still thinking of like ways we could design a nice system. So I mean, we have the screwing plate right on here. The point where it gets screwed in is on top. So what I'm thinking is like if we make like a permanently fixed connector down here, this would be like annoying to plug in, right? Because like how do you connect this bar, like this metal piece that is like on top? Now you want a fixed connector down here somewhere, right? Where you plug the battery in here, and it connects automatically to like the fixed connector. That's not possible. So I think, yeah, I'll definitely have to let go of that idea. So then the idea only becomes like, how do we terminate? How do we switch from having these, you know, now it's just folded up, some connectors, like some, how's it called again? Nickel strips, like only the folded nickel strips. And now we want to terminate that into a XT60 connector. So that's kind of the difficulty. Like, how do we terminate in a XT60 connector? I have some kind of idea. Well, actually, let me pull up one of my old designs. Oh, maybe let me just push that to the other screen. The issue is I have a lot of like stuff on here I don't want to leak. So I think this was like my e-board design also. Yeah, I think here it was somewhere. Yeah, it's open to e-board vest casing. So here I have it. All right. Up here, there's also like a XT60 connector. I also have this on like on 2 places on my e-board. The thing you can see on here is like a rubber gasket, but that never worked out as well as I thought it would. So that's a stupid idea. But this is what we're interested in. This part. Yeah, let me think of it. So this would be like the optimal solution, I think. This is not too thick. It's only like a few millimeters, and this worked very well. Like pushing in the connector here, that worked perfectly. So I'm thinking of going with kind of this approach. But now, since we don't have like a mounted permanent fixture of the other connector down here, we now need to basically make this so you can push in the battery and either then plug it in, or first plug it in and then push in the battery. I think the first solution would be like the easiest way. So it would be like you take out the cable. The cable has like a little bit of give to it. It's a little bit longer than it needs to be, and you plug it into like the battery, and then you clip in the battery into the vehicle. So you could either do that, or you could clip in the battery and then take the cable and plug it into the battery. But in the first case, you could, you could in theory make it that the connector faces kind of this way, so it faces towards you, and then you plug it in, and then you clip in the battery. But if you want to make if you do it the other way around, you need to design so the connector shows up to you, so you can plug it in from the top, because you don't want to fiddle around, like you don't want to fiddle around on the back. So yeah, I think definitely like let's make it so you plug in the battery first, and then you push in the battery into the vehicle. So that means the connector will face downwards. I think that's at least the easiest solution. So let's design that, right? I'll just copy whatever I have here. Actually, can I just... I designed this so well already, I don't know if I can just rip it out of here. Let's see if that will work. So what I want to do is create like a sketch around this. And then just pull out whatever's around there. Cut it. Yeah, it should work. And then there should be like a new body right now. Not this one. Oh my god. Ah, it's this one. Okay. So now we have like the raw thing here, and if this will work. Let's see. No, this doesn't work. Oh, I did this before. This is super annoying. How does that work again, right? That's like the most annoying part. Copying a body from one project to another. Nah, no, it's not that easily possible. There is like a solution for this. Let me Google that. Fusion 360 copy body to another project. So I'm not the first one who want to search this. Insert command, drop down menu. Okay, all right, there's an insert command. That's interesting. Right. Insert. Ah, that's good. Actually pull that to the other screen right now. Insert. Sing. Keyboard. Also put it keyboard VESC. I should just export this first, right? This would be the easy solution. Let's export this as a separate... Yeah, let's just save this as a... create component from body. I don't get it. This is super annoying, like honestly. Copying stuff from one project to another. It's like the most annoying part ever. Save as xt60 plug. So we exported now this xt60 plug as a separate thing. So now I can go insert and then hopefully select this. Right. What the hell was that? With the same hub and the same project, we see. What the hell? Insert. That's super annoying. I still don't get it how it's done. Click a component and copy. Alright, let's try this. Let's go to the component level. Right? This is the component. And want to copy it, right? Copy. And then go to our thing and then paste new. Yeah, I think we got it. All right. Now we need to trim off all the excess because there's a lot of things connected to it. All right, we only want this one, so. Oh God, I deleted the wrong stuff. Okay, oh, this doesn't work. Why can't I delete one thing? It deletes everything. That's insane, okay. Why does it delete everything? That's so stupid. I don't get it. I just want to keep one thing, not everything. Create new component from body. Let's copy it from here to paste. Yeah, okay, now it works. All right. I think we got it now. Okay, now I should be able to just delete that. Delete. Delete. Yeah, I think we got it. All right. That was super annoying. Oh my God. I think, oh, no. Oh, okay, now there's no reference to it. Okay. Okay, 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 I got it. We need to keep this in. I don't care. We'll keep this bulk in here. So yeah, that's really like annoying process. It's just copying a part of a project over to another. So this is our xt60 plug right here. Right, this took a while. All right. Now we can move this. Set pivot, free move, translate. Actually, we should be able to just, I don't know, tuck this to this. Is that possible? Ah, point to point. There it was. So we want to make like a point to point. Nope. Nope. Point to position, translate, free move. I don't care. Let's just move it around. There's a command for that. I don't want to do this. This is stupid. translate. I just want to be able to like warp it to another point. Rotate point to point. Origin point. All right, we got that, I think. Origin point. Ah, now I think I have it. Yeah. Okay. Now it's good. That actually what should be our target point? Let's just, for the sake of it, just transport it over here. No, here. Okay. Yeah, that's what I wanted to do. All right. Yeah. So, yeah, we want a connector facing downward, so that's already not too bad. All right. Okay, now we want to turn it 90 degrees, something like that. So now we should also decide where like positive and negative terminals will be, right? The side will probably be negative, right? The XT60 part, the connector, it has the smaller side is the minus terminal and the larger side is the plus terminal. For all of you who don't know what XT60 looks like, this is the XT60 connector. This one. This is like the default plug you use for high current applications. Yeah. It's really cheap, that's why everybody uses them. Yeah, so let's do next step and let's do another move of this thing. Okay, origin point from here. Actually, let's do a smart thing. I think this would look cool. Let's do origin point and set the origin point on this area right here and do the target point to this area right here. Why doesn't it work? Oh, selection. I did something wrong. Let's try that again. XT60 plug, right? One selected. Okay, point to point. Now it works. This right here to this right here. Okay, looks good. So now the plug just comes out on this side. I think that would be, yeah, that would definitely be possible. So let's continue with this sketch. Oh my god, no. Okay, that sketch was pretty useless. Let's delete that sketch. Oh my god. I actually referenced the sketch. That's stupid. Let me see. Where did I mess up? All right, this looks good. So I think the last thing we can do is provide some canals for the cabling to route here through, and then also open up for our balance connector. So I think the easiest solution for the balance connector would be to just have it pretty open. So I would honestly just run out like a connector, like honestly just run like a big connector, like, you know, like it's on here. Just run out the connector. Nobody cares down there. I don't know. Maybe we can wire it a little bit further down so it doesn't get splashed by dirty water or something. That would be like a smart thing to do, maybe. Other than that, I think there's not much we can do for it. Oh yeah, right. We would also need, because it's a balancing connector, we would also need like balancing leads not only on the top but also on the bottom. So we need to kind of combine them into one connector. Or we need to route like the cables through here. That would be actually so much smarter. Let's actually do that. That would be so cool. Let's do some channels through this here, through these. And then we can just route out the, you know, we could in theory, like, because like a lot of the cells terminate on the bottom and the top, we could, you know, split it up and then just each cable runs either on the top or on the bottom. But then you would need like 2 openings. You would need this opening and you would the same opening down here. But I think the way smarter solution would be we run all the cables down up here through this opening, all of them, and they all shoot through here, and then they terminate. Some of them terminate on the top, obviously, and some of them run to the other side, right? So right back here, we have so much space left, so we just drill some holes through this, right? And wire the cable through that. We could also wire through this, so there's a lot of space left, right? I think that would make sense. All right, let's do that. Let's do like a sketch on here. Let's project these and this and that on there. I'll probably just do like a rectangle. I'll do it very roughly. Actually, let's do like a symmetry thing. I don't want to mess anything up. So we're doing like a symmetrical line here. This line is just for sketching. Oh, that's a stupid line. Why the hell did I split that up? Okay, again, like this. Press X. So now we're around here. And we need symmetry from this point and that point. No, that's not the symmetry I wanted. Okay. Now the symmetry is broken. Great. All right. We need symmetry from this and that. Okay, that doesn't work. We need points for that. So we need symmetry from this point and that point to this line. All right. Now it's symmetric. And now we can just do stuff on here, like create a rectangle with the center, like that. That would be fine. And another one up here somewhere. Something like that. This would look fine. And then just mirror whatever. Oops, didn't want to do that. Mirror this, this, and this along this line. Press OK. And then we have some cable channels that run through the whole battery pack. Right? All right. So now we can basically terminate all the connectors up here. And then again, we have 9 millimeters. Let's see if that's enough. It's kind of tough actually to say. And let's actually measure out how many we need. 3 less, something like that. Okay, we need like 10 millimeters, so that was a little bit closely calculated. So this opening for our balancing connector is a little bit too tight, so we need to make that a little bit wider. So let's go back in time to when we actually did that opening. It was somewhere around here. Yeah, there it was. Let's edit the sketch. Let's make this more 10 millimeters, right? Finish the sketch. All right. Looks good. All right. So I like how it currently sits. Like the XC60 connector looks fine on there, honestly. Like most of the things I see, I really like already. Check something really quick. Apparently not that much. All right. So let's build like a wall around this. Let's build like a kind of, I don't want to make it too fancy, but and I want the cables to terminate somewhere around here, so it doesn't look too ugly. How high is this? This is 12 millimeters. Okay, that's fine. So let's build like a 12 millimeter wall around here, something like that. I think we just make it square, right? That would be like easy. Let's project this side. Project. Let's add a sketch on here. We have this already sketched out, so it's going to be easy. Like, oops. No, that's a stupid line. Let's do it again. Something like that. All right. This line, let's make it invisible, and let's make this line sit on one of these points. Then let's draw a line from here to here. And then draw another line from there to there. Here to here. All right. So I think we got this. How thick was this? This was like, let's measure that out. 1.95 millimeters. That's like a weird measurement I did there. I don't know why I modeled that with 1.95 millimeters. Like probably the same on this side. It's not the same. Okay, I don't know what I did there. Like that's kind of random. What did I do there? These are some weird measurements. All right, but that should work either way. So I think what we will do is do an offset. Do an offset of this, this, and yeah, already. So something like -2 millimeters, right? Yeah, makes sense. And then let's pull this in from here to here, something like that. Does that make sense? Yeah, it makes sense. Let's make our life a little bit easier by also filling in this gap here underneath the XT60 connector, right? That would make it a little bit simpler for us. So we're going to make a little square from here to there. Oh god, it's not projected. So let's project simply this. Project this to there. And now we should be able to do our rectangle. Yes, that is possible. All right. All right, first things first, we should extrude this into there. Make like a distance to object. Ah, no, that's not good. Object. All right, let's see. Yeah, that worked. Okay. So now we have this connector sitting flush on here. I can re-enable the sketch and basically pull out all this stuff. I don't want to do full 12 millimeters because there's going to be sitting like a roof on there a little. We're going to glue a little thing on here. Yeah, okay, that fits nicely. So sounds about right. I love how now everything is the XT60 plug. Okay, we're going to name this cell body. All right. I think we're already pretty good shape. So now we need like a place for the balancing connectors to come out of, right? I would prefer like for them to come out here in the middle somewhere. So I would now design like the top of this, the lid, and with that we should already have like all the other pieces done. Right. So let's design a lid for this. This is, by the way, I'm doing a lot of rough sketching right now, so I'm not really like having any, like usually you would set up parameters before you do any of this stuff I do, right? So you can yeah, you can have like this parameter list, and currently right now you can see this is like the permanent parameters I set. You can see them right here. Like there's some calculations I did for some of the stuff, but a lot of these measurements right here, like I didn't name them. I didn't like do anything. Like I don't know what this even is. Like I don't know what's 140 millimeters. I don't know what the measurement is, because usually you would go in from the other side. You would usually like first lay out like how big is your battery, how big is this, how big is that. Name all the different measurements you have for all the different objects. Like take measurements of all the objects, of all like battery cells, of the connectors, things like that. And then you can just type in the connectors and you automatically assign all these different measurements to them. That's usually how you would work, but I want to do like quick prototyping, and I don't care about like there's only me working on this design, right? So I don't care if anybody else is not able to read this design, because it's like, yeah, I'm the only one working on it. Yeah, so actually now let's do a offset of this stuff right here. Let's do a sketch. Let me think how we can do this the easiest way. Going like 0.3 millimeters, something like that. Also sketch 2. Also connect these lines together. And then I would do another, no, let's not do an offset of the offset, that's stupid. Let's do it like that. That's way smarter. Now you got all these insane measurements everywhere, but hold up. Okay. To this, no. This to this. All right. All right. So we're going in -1 millimeter from this side, and then to the other side. Kind of need to edit the sketch a little bit more. We need like a rectangle on top of all of this. And we should maybe take off some of this stuff right here. Oh my god, it's not even projected. Project this to that. And then we could take off the measurements right here as 0.2 millimeters right here. Should be 0.2 millimeters right here. So there's like a little bit of clearance issue I'm already like getting a sense of, because we want like a cover plate on there, and you can easily like design this the wrong way, right? Like if you design the cover plate, I don't know, a little bit wrong, this is annoying. So yeah, that's why I'm making this like creating some clearance in here, so everything will fit nicely together in the end. So this is going to be like the top of it, but now we need to hide our cell body. Let's see, let's make this. How big is the current thing? Oh, that's big. Let's just go for 2 millimeters. That sounds nice. Yeah, all right. Sounds good. Cell body power cover. Oh, holy shit, what am I talking? Power cover, right. Right. Yeah, that sounds nice. There's some clearance in here, so I think this will fit. Most of these parts, since I don't plan on making this like a super, I don't know, there's nothing to repair, right? It's like the worst thing that could happen is like a cable breaking off or a connection being loose. And I don't expect that to happen at all, right? And it's like the bare minimum a battery pack can be. There's not even a BMS in there, so like you don't need like great repairability or anything for this project. So I'm going to be going for like gluing on the covers. On the last one of the last projects I did, let me think, what was it called? The electric skateboard I did. A lot of people were talking about the fact that I glued on the battery covers, but this was also done because like you save a lot of space with this. Like instead of screwing on stuff and like how do you get this stuff even like watertight, right? Water can get in everywhere. So like a normal gasket is not enough. Like if you just put like a rubber gasket around there and some screws, this is not going to be watertight. There's going to be water coming into your battery in the long term if you want it or not. So there's not really like easy solution to not get water into your battery. So next step is going to be let's design these covers actually. And also like next step will be ordering batteries, right? I don't have any batteries ordered yet, so we also need to place a big order of all the things I will need later on. Yeah, all right. So the connector goes in here. Clearance should be fine on this. And on this side, yeah, looks nice. That will work. Also, like, I love how 3D printing allows you to do like crazy stuff. Like, honestly, this would be like unimaginable. Like, you can't injection mold this design. This is stupid. Like, nobody would injection mold this for you. So I love how 3D printing just allows you to do stuff you were unable to do previously. It's amazing. Let's continue. Let's design like a nice bottom for this. How can I go about this design? So we have like zero space. Like, I'm not even kidding. This is like the tightest stuff in here. So what I'm going to be doing is like designing like the least, like the thinnest kind of battery cover you could imagine. This is going to be 0.5 millimeters thick battery cover. This is going to be like really like flimsy, but it doesn't matter because like the battery is like kind of the whole structure of the pack, right? It's glued in here probably, so the battery is going to be holding everything together. Yeah, let's continue with that. Okay, first step would be to design like a rectangle around here, something like that. And this should have like an offset. Let's see how much offset. I see distance from this to that. 1.6 millimeters, right. What I thought of just a minute ago would be like, I would also like really enjoy like playing, I don't know, Counter-Strike or I don't know, some other game live on stream. Like there's a lot of games I really enjoy recently, so maybe that's also something I should do one day or another. Like stream some games. Maybe it would be fun. Anybody who's, I don't know, who's known this channel for longer knows that I actually started off as a gaming channel with quite terrible gaming videos, so that was fun. Let's go for the 1.6 millimeters. So we got the same distance everywhere around this battery pack. And now we should also do like a rectangle inside here, but I want to do this as like an offset for this. So let's do an offset from this. Offset. Ooh, ooh. Something like that. When Mate is riding, we can play Counter-Strike. Sounds good. Let me check Discord for a second. All right. Oh yeah, there's already some people online in my Discord. It's also funny, like Discord automatically detects that you're that you are live streaming and already warns you that that you're inside, I don't know, some streamer mode. I don't know, probably stuff gets censored, things like that. That's funny. Yeah, now let's design the battery. We're almost done, I think. We're taking this outer measurement and then going in like 1.3 millimeters, 1.5 millimeters. Something like that, maybe. Let's actually go in a little bit deeper. Let's go 2 millimeters. Nah, that's too much, I think, right? No, we should be fine, right? Yeah, we should be fine. Okay. This should go in like this, gives this the whole back plate some structure, right? So it should go down like maybe 1 millimeter or something. 2 millimeters, no, 1 millimeter is more than enough, I think. And then we should hide like the whole, yeah. And then the top is really slim, like this is the thinnest part. So we go up like 0.5 millimeters. Join, like that's also something that's annoying. Like I can't select what it's joining. So yeah, I'm just going to, the easiest way to select what this extrusion will join is just to disable whatever you're viewing. So in this case, yeah, as far as I know, that's the easiest solution. I don't know, maybe just a simpler one. I think that works quite well. And that's also like, I don't know, I like the fact that Fusion 360 is so visual about everything you do, right? You see how things move. Like if you're extruding something, you see everything that's before you actually apply it. And that's way easier than, I don't know, CATIA or something where you just type in commands and like a crazy hacker, and then in the end you're getting like a model, but you actually don't see it until it's like done already, and you can get pretty frustrated if stuff doesn't work on the first try because like it takes a lot of time. I just want to lower my seat a little bit. There, perfect. How do we go about this? Okay, so this is one of the side covers right now. And in theory, this is just the same as on the other side, right? So I'm not doing this again because this is obviously already cell body side cover. Oh, I forgot something, right? We need to have like a point where all the connectors come out for the balancing. So my idea would be, why not pull out all the wiring somewhere around here on this side, right? It's only like a really small slit anyway. And that gives me another idea. Why the hell did I put that thing even in the middle? I could have made this design a little smarter, maybe. I could also run with my arrow and just, I don't know, ignore it. Yeah, I think the XT60 connector would be way smarter if it would be like on the side, and then I could do like the balance connector right here. I didn't think of that before. And now I don't want to change it because it's like too much trouble. Maybe I'll do, let me think. Yeah, I should definitely actually move the connector over there, but that's way too much work right now, so let's just keep going. Dig ourselves a hole of bad design. All right. Shit. This was like, so the space we actually is like 1.4 millimeters thick, so that's pretty slim. 1.4 millimeters. So in height we need like 1.6 maybe. What the hell? Something's not working right. Let's do this again. Now it works. And then like 30 millimeters in width. It's super annoying, honestly. Okay, I'm redoing this. This like I want this so badly on the side. I can't even express it. It's insane. All right, let's do this again. Okay, I think that's a nice move right there. Okay, and now we should take this body right here, do a free move, and just move it. I don't know, something like that. That looks better in my opinion. All right. All right. Okay. Now let's see if this sketch will work out, right? The sketch it's still the same, right? Okay, that will work out perfectly. That's also the extrusion for the sketch. Then the next step was, let's see, something like that. Okay, see that's already like Fusion 360 is so smart. It already knows like what kind of stuff I did, so it fitted everything. So that worked out. This will work out. This will work out. What the hell did I sketch on here? Let's look at the sketch. Yeah, works. Then it's the next step. This inside piece, outside piece. Oh my god, I love Fusion. It's so smart. Okay, alright. I think got it all. Yeah, okay, that was easy. Alright, now we got this on the side. And now we can do it the clean way. Right. So again, we need like 1.6 millimeters in height, 1.6, and then in terms of width, we will need something like, actually I should check these connectors. How big are these? Because they're not all the same. 1.4. Yeah, 1.6 is pretty close. Okay. Yeah, and then something like 13 or 15 millimeters from width. 14. And then with this a little bit bigger, 1.8. Something like that. Okay. And now let's center this, right? So let's make this symmetric. It's not possible, right? It's like this, and this. All right, I have no idea how to make this easily. This is usually the easiest way to make something symmetric. Just draw some random lines in there. So this is already symmetric, I think. Yeah. 50.35, 15.35. All right, that works out. And then now you can do like this, and that should be symmetric to this, and this, and that should be symmetric to this. Sketch done. Let's remove the power cover. To object, to this one, cut it, and we're done. Hi, Alexander, how are you doing? Yeah, I actually want to do like a more regular streams, right? Like this would be, I think this would be fun to like every time I can't do this about everything. Like if I'm soldering or having something like that's really complex, like this would be way too distracting, honestly. All right. I think the design is almost done as far as I'm concerned. Honestly, this looks kind of good already. I want to see a render of this. Let's do like a stupid rendering. Doesn't make sense right now, but hey, I want to have fun. All right. Hell yeah. Look at this sexy piece, and in canvas render, let's do this. I hope my GPU doesn't die while I do this. Oh, I just realized I get I haven't given this thing any material properties, so this is going to look terrible. It's going to look so glossy and like reflective. You can already see like the ray trace glossiness of it. So that's not how plastic works, right? So we'll have to jump back into the design and assign some materials to this. So let's actually open our appearance tab. So we're going to search for plastic. And we're going to take like plastic ABS white, for example. Boom. Also for this side, ABS white. Boom. And last one, ABS white. Boom. Oh, actually, let's do like different kinds of. Let's do like one. Be a nice color. Let's do red. Like a not so very strong red, like something like that. Looks nice, kind of. And then let's do another. Let's do ABS white on this, and let's edit this. Okay, yellow looks terrible. Like blue. It's like blue. Cool. I don't know, it looks kind of stupid actually. Okay, I don't care. Let's do a render of this. I want to see how that looks in actual light. So something like that. Yeah. Okay, I think I need more light. This is really dark. Yeah, that's way too dark. Last time I joined your stream, you swapped your keyboard switches. Yeah, I did that. Like, that's the keyboard I'm currently using still. Honestly, I love it. Like, I switched to Cherry from Cherry MX Black switches to Cherry MX Brown switches, and I love the transition. Like, honestly, they feel so nice. I love the clickiness of it. I actually loop them all, and I don't know if they feel amazing. They sound amazing. I'm not like the biggest like mechanical keyboard guy. Like, I know there are some nerds on the subreddits and forums that go like that go crazy for these like clicky and not so clicky and thumpy or whatever like switch sounds, and I'm definitely not one of them, right? So not yet. But like honestly, I love the switch from the Cherry MX Blacks to Cherry MX Brown. They feel so much nicer. Like honestly, I love like the little tactile feel. You feel it on every stroke. Like a keyboard I also love is like from my MateBook. Like this keyboard, this is also like really amazing. Honestly, I like typing on this. This feels like the MacBook keyboard kind of. It's really similar at least, and I love like the clickiness of it. I don't know if you can hear that. No, it's too quiet, I think. But yeah, sounds amazing. I love a good keyboard. It is amazing. I just looked. Yeah, like honestly, designing battery packs like this is just honestly this is like just like a cell holder. Like this is not a real battery pack. There's no BMS in there. This is just the plainest, simplest version you could do. Yeah, this is just for fun actually. Like there's this will go into like an e-scooter, but I wouldn't recommend this to like anybody who's trying to get like you can't sell this, right? It's like something a customer could work with because this is like doesn't have a BMS. It's just basically a cell holder. a glorified cell holder with some, because you know the whole point of this project is basically for my e-scooter. Let me show you the pictures because I talked about this earlier and maybe some new people joined. I want to find the pictures. Here they are. This is the e-scooter I'm talking about. Hold up, get a better picture of this. This is the e-scooter I'm talking about. This is what it looks like, this one here. And so I stripped out all the electronics because the electronics are quite bad, the battery is quite bad. And I want to put in like new batteries, and there's actually not much space in here, as you can see. And the only thing we can mount to are these metal pieces right here. Right, so let's see if you can show this to you really close. So you can slide them in, right? This is the only part we can mount a battery to. And what I want you to have is like this kind of battery, like have an XT60 connector and the balance connector hanging out, and then you can just connect it to like one of these RC things. I don't know how they're called. Hobby chargers. I don't know, 6S hobby chargers. They have on the side, they have like the balance port, and they have like the XT60 port right here. And this is so amazing. This honestly, this is the best way to you can just skip out the BMS, save a lot of space in this case. I wouldn't recommend this for anybody. This is just for if only nerds will ride your electric vehicle. Otherwise, this is not recommended, because every time you need to charge, you need to pull out like your hobby charge or whatever, and yeah, it's quite a struggle. Yeah. Yeah, I think this looks really nice. Also, you can see like down here. Oh god, I ruined it. I thought I could zoom in. No, it's not possible. It's because it's like it's not. It actually has perspective, so. Yeah. But I'm going to take a quick break right now, I think. I'll be back in just a second. Like honestly, there are good battery pack companies out there, like EM3EV, for example. They make good batteries, right? I don't know if you've ever heard of them. Open up my browser window. They make like, honestly, if you hold up, I think I wrote something wrong. Oh, okay, I did everything right. All right, they build like amazingly nice batteries, right? These batteries, like you can't build any batteries yourself that are better than this. I think they even have like cell level fuses and stuff like that. I don't know if you can see that. Let me show you. Yeah, but there's like cell level fuses, so this is like the top end battery pack, right? It's also the price is quite high, but that's understandable, right? If you want a great product, you have to pay a great price. That's usually how it goes. So, but this is honestly like the top level kind of battery pack you would want, and I think these are like recommendable, right? But the price is obviously very high. But if I would buy something, then I would buy definitely this. In other cases, I would definitely build it just myself, right? There's a lot of fun to building this stuff yourself. By the way, speaking of building stuff yourself, I got a nice package the other day. A spot welder from this one company. So they actually messaged me a while back. And I'll probably make a review video about this, right? So that's going to be fun. Yeah, I don't know if the live stream will stay online after this. I actually planned on doing it because some people already asked for this, if this can stay online, but currently I don't know, because honestly, like live streaming, there could be going so much stuff wrong, and I don't want to have this stuff permanently saved on the internet. I don't know. Maybe I'll download it and make like a cut version of it. I don't know. Maybe cut out like the interesting pieces of it. That could be like something. Otherwise, don't know for sure right now. What recommend for a bike BMS? Something. That's funny that you ask, because actually that's one of the things I always think about, because there's currently like no like great BMS systems out there. There are some open source systems people are working on, but like there's nothing like really useful for most people. So I hope nothing weird pops up, because AliExpress can be very weird sometimes. So smart BMS. Ah, that's amazing. All right. So these are like smart BMS systems right here, and no, they're not smart BMS. What the hell is this? Smart Bluetooth BMS. What the hell is going on with AliExpress? So these are the ones I would recommend to like most people. These are the ones I recommended in the past. They are okay, but the app is quite shitty. Like honestly, the app is terrible. The app is called Lithium Battery BMS, or that's at least how the company is called. Lithium Battery PCB, sorry. This one right here. That's the company that's actually, as far as I know, like I can't track down all the sources, but I think this is the company actually producing the battery cells. I'm talking about, this is the company that actually produces the BMS systems. And as far as I know, like they always have like the newest software right here. Like if you want to have like the newest Android version, you can download it right here, the 3.1. If you have a Xiaoxiang BMS, like the Xiaoxiang app and everything on your phone, definitely update that. It's gotten a lot better over the last few years. So if you want your battery system on the newest state, definitely update it. But these battery systems, they are quite recommendable, honestly. Like I like them. They're not perfect. There are some issues to it. That's why I always think about, like, I don't know, if I want to design like my own battery management system one day. I'm currently already involved like in so many stupid projects. It's ridiculous, so I don't want to get another thing on my list, but there's just no perfect solution out there. There are good solutions, but like the VESC, for example, was like a perfect solution, I think. Like as long as you have like a TVS diode and run it on like 10S maybe, then it's like VESC is like was like the perfect solution for motor controllers, the VESC. So I didn't find any interest in like improving that kind of thing, because I was like, yeah, it's already out there. Like I could work on the design and maybe improve one or two things, but it wasn't really worth it. So I found myself spending more time on other things. Like for example, on my electric skateboard video, I showed that I mainly worked on like the mechanical side of it. I want to improve like the mechanics of it, and I also wanted to have like a really good remote, because at that time I didn't feel like there was a good remote system out there that works perfectly. So these were like the two main focus points of that video, because I realized that there's no good remote out there for eSkates, and there was no good like safe system to reliable system that the mechanics don't break. And also like the TVS diode was a big thing back then, because nobody used a TVS diode on their PCBs. Now I actually wrote to some manufacturers that this is like a big issue, and they should definitely put in like the few cents for a TVS diode, and some of them did. So that's good to hear. So I hope there's less VESCs breaking out there. Maybe. Collaboration with Great Scott, yeah, that would be like the perfect collaboration, probably. Two very German guys talking about battery BMS systems. But yeah, I don't know, it would be like a fun project. One thing I'm currently working on right now, it's also kind of related to like the whole charging battery system. We're currently doing a how's it called again? So the idea basically behind it is you want to have like, I did this in the past, right? There's this USB-C, like this video right here. Let me show you. This video right here. Oh my god. These ads are getting annoying. All right here. This whole video was basically about designing like a small USB-C battery charger, right? And in the end, I had this small charger, but I felt like you could get the size of this way down, right? And I still think I'm right. So I think this is like a terrible size for a USB-C charger. So you plug in your USB-C cable on the one side from like you get your laptop wall charger, right? Plug it in, and then you can charge your battery with it, your e-bike or whatever. I think this was already like a nice idea, but I wanted to get this further. I want to make like a small PCB that you could put inside your battery and then just USB-C charge everything with it. Like that's my dream kind of charging solutions for most of these things out there. So that would be like getting this thing down to like a small PCB, which I think in theory would be possible, would be like my dream. So I'm actually currently working with one of my colleagues from studying on exactly this issue. Like we're currently trying to figure out, can we make like a small PCB of this size? I only did like one PCB design in the past, like no, actually not one, multiple, but in general, like from the ground up, I only did one single like full PCB design. But so I'm not like insanely experienced on this topic, but I definitely have like very high interest in making like a small USB-C charging system for e-bikes and generally e-boards and small electric vehicles. I mean, come on, that would be like so awesome. Just, plugging your USB-C cables straight into your battery, nothing else needed. You just plug it in, it just works. Behind the curtains, there's obviously a lot of like technical stuff going on. For example, you first need to program your USB-C charger. The box the PCB you put inside your battery, you need to program it to which voltage and which amperage it can charge your battery up to. And then you would also need to, add like different profiles. You can switch through them with the external switch, something like that would be possible. But yeah, for the first idea, I want to go for like, this should be like a PCB, and you can solder on like there's like jumper soldering points on there, and you solder on if you want to have like 12S, 10S, 11S, whatever, like 9S, 8S charging. And depending on what you solder, there's a little microcontroller on there that automatically detects what you want to charge with, and then automatically sets the voltage and also amperage obviously correctly. And this microcontroller also speaks to the USB-C charger, so it figures out how much amps, how much voltage it can be pulled and stuff like that. Yeah, that would be like my dream USB-C charging solution, and I'm currently trying to figure that out. The Meepo remote, yeah, I've seen that kind of pistol-looking one. I think it's just kind of like, I don't know. I would be scared to ride around with a thing looking like a pistol. I think people have been stopped by the police because of that. So, will you stream as often as you upload videos from now on? So every half year? Yeah, definitely. No, I don't know. Maybe I'll do this more often. I don't know. I could do this more often, right? It's just the same thing. Like either I sit at home and work on this stuff, or I show you guys and work on the stuff. So yeah. So yeah, let's actually continue with this design, I think. Yeah, I want to take a quick break actually. I'll be back in just a minute. Maybe. Yeah. we back, baby. So let's do this. All right, I think we're almost ready with this design. Hey, Crazy Kicks. All right, I think we have like everything designed already. We got the balancing connector right here. So like the last step usually is to round off stuff. There's a lot of like not so nice looking pieces in this whole thing. So we run around round up stuff. So let's hide, for example, the covers, right? What you need to round off is like corners like this, like edges that are just way too harsh. Yeah, let's do that. Chamfer. Chamfer here, chamfer there. Chamfer everywhere. Not this one. I don't want to select this one. So something like that. Also this corner right here. Also there's going to be like dirt collected on here, so you usually don't want to have like so chamfers can be quite useful. I think this looks nice actually. Yeah, that looks kind of good. Should I get chamfer on here? I don't need it, but let's do it anyway. 0.1 and 0.5, something like that. Now let's actually make it bigger. Yeah, looks good. Do we need another chamfer somewhere? I mean, these kind of holes, like they already come out like pretty rounded usually. Like if I print this like that, when the printer heads goes around these corners, it kind of rounds them already off. Like it's not going to be like perfect angle, right? So that's going to be interesting. Werde ich öfter streamen? Ja, habe ich schon vor eigentlich, aber keine Ahnung, ich weiß nicht, je nachdem wann Zeit ist. Like I like to stream when people want to watch this stuff, like yeah, sure, I can do it more often. It's like this is the kind of stuff I don't know, I do in my room anyway, so might as well share it, right? If somebody's interested and can maybe learn some stuff from this. All right. Let's continue with this design. So get this right here. This should be able to print just fine. I'm thinking also of ways like I want to print this from, you know, some direction, probably from this. So this is going to be like the bottom, right? I'm going to print this from the ground up. So the idea is usually like, how can you assist your printer in ways that he doesn't have to print like, I don't know, kind of crazy overhangs and things like that. But there's like not much on this, in this case, I can do right now to improve, like, to help the printer. Usually when you have like a small like overhang somewhere, like something like that's really small and just crosses a quick point, you can maybe round it off a little bit. Let's say, I don't know, let's make an example actually. Let's say I need to have like, I don't know, something like a little extrusion on here, like 1 millimeter extrusion, right? So now if I would print this from the ground up, now the printer needs to put in here like a lot of support material up until this point, right? It needs to build all this support material just to print out like this small piece here. Now you could in theory print this without support. You could just say to the slicer software, in my case I use Cura, this right here. I could tell my slicer software, like, ignore this, like don't do any support material on here on this small edge. So I could tell that the software, right, don't print on here, don't do any support material right here. But then I would run into issues because like this is not like, if somebody else wants to print this, or if I reload this design later on, like that's gone, this information. So this is going to be printed again with like the stupid amount of support only for the small section. So the easy solution would be like to think of ways you can counter it. Let's say this edge needs to be you just need an edge here on the side or on the top or somewhere. Yeah, no, the easy solution would be to do like a chamfer. Well, not that chamfer, and do like a 1mm chamfer right here, and boom, you're done. Like now this can be printed without support. So that's usually how you go about this stuff. Let me delete the last two ones. Yeah, so I usually want to think about like ways I could help the printer not use any kind of support material at all. That's my goal, my end goal usually. Which kind of filament I will use. So the filament I currently use is like, I don't know, some cheap PLA I have laying around. Some of this stuff is from Filament World. Some of this stuff is, I don't know, from random places I found. So this is like, I used to order a lot of filament from this side. They make like great filament. Like honestly, this is like amazing stuff. So what I would order, this is the stuff I usually print with. It's called PLA Plus. Amazing stuff, like honestly, this is good. The black one. Here's another pro tip right there. Always, like if you have like something technical to print, always use like darker-ish colors. Because, you know, heat is just a way of, like, it's just radiation, right? It's just, heat is just infrared light. So if you want to heat something up, it needs to absorb a lot of, like, radiation, a lot of the infrared radiation. So if you have, like, white filament, for example, it doesn't heat as easily as quickly up in the extruder. So you have, like, I mean, if you look at it like a 3D extruder, right? At a nozzle, like the nozzle, it's just a small piece, right? And this small piece, like this small cross section here, is responsible for all the material to melt. Like when it comes out here, it needs to be melted completely. Like it needs to be all the same temperature, right? So you want your material to heat up as quickly as possible when it runs through this. So the easiest way to do that is to use a more darker filament color, right? Something that absorbs a lot of like the infrared light. And I wouldn't, if you do like technical prints, you can usually even see that, like especially on cheaper printers, you can see that white filament doesn't print even remotely as good as pure black filament will do. So that's really important. So always use like darker filament, especially on cheap printers if you print like a little bit quicker. That's something good to know. Okay, all right. I think we're done. Actually, I could start the print right now if I wanted to. Like I have the printer in the next room. Let's see. That. Oh, it seems like my 3D printer isn't online currently. I don't know what happened. So yeah, I'll have to figure that out. Okay, my 3D printer is currently not online. Let's check if it's actually like gone or whoops, I didn't want to do that. Oh my god, I closed everything. All right. All right. I think it's not. No, it's not. Let's go for an SSH. Nope. Alright, my 3D printer is currently offline. Okay, have to cancel that. There's no getting into it. Okay, either it's just unplugged or something weird is going on. Alright. So another design I can show you really quick is something I worked on for a while. Okay, this is really stupid. There's actually somebody already out there already who invented this before me, so I'm not the first one, right? This one right here. This is really stupid and fun. All right. 20 projects. Yeah, thanks. Thanks, Kenzie. I don't know how you pronounce your name. Hey, what printer do you use? And do you have any modifications on it? Okay, I use a ANET A8, and it's really modded out. Like, I don't know, it's not really a ANET A8 anymore. It's like a weird mix of like, I don't know. It's really I've changed like everything on it currently. Like, there's still acryl on it, so it's still an acryl printer. So there's still like vibrations on it, so it's not a perfect. I didn't swap out aluminum parts or anything like that, but I don't know, a lot of the stuff that was annoying to me, that's kind of was proven to, I don't know, be unreliable and things like that. I swapped that out, so I honestly can't go over all the modifications I did. There's like too many modifications I did. It's like, I don't know, 20, 30 different things I did. Yeah, I think, Alexander, I think that's the way to go. Just I'll open Octoprint and let you guys watch, and I'll watch it myself, right? So it's quite hypnotizing watching a 3D printer for 20 hours straight. So what I want to show you, actually, this is like something really stupid. Like, somebody already did this. This is a product somebody already sells, but I wanted to change a few things, and I think I have some funny ideas to improve it. So this is really stupid. This is a I don't know if you could tell it. I think nobody in the chat will figure out what this is for. Or does somebody have like a clue what this could be used for? I don't think anybody knows what this machine is made for. So I can show you. Hold up, inside maybe. So the inside there is a spring. It's no, not up here. The spring there, it's inside here. So there's a spring inside there. That's a little hint. But other than that, so how it works is basically you press down from here, and the spring basically pushes back. So every time you let go, it just bounces back. You fill this thing up. You fill it, yeah, I think Knickknack's already pretty. Like, you fill this thing up with like nuts, like, I don't know what kind of snacks you enjoy, like I don't know, some walnuts, some whatever you like, hazelnuts, I don't know, all kinds of snacks. You can fit M&Ms in here, so M&Ms will fit in here. Yeah, Knickknacks, like, you can fit in all kinds of snacks, but I honestly would keep it like to like normal nuts. Actually, I don't know what the hell is a. Ooh, let's learn some English. That's right. Peanut. Oh yeah, peanuts, right. So, peanuts. That's what I designed it mainly for, peanuts. Yeah, so you fill this thing up with peanuts, and what this mechanism does is basically every time you push down, this little lever comes here into play, and it kind of blocks the way for new nuts. So in this case, you fill it up with nuts, and then you press down, and then every time you press down, a little portion like a few nuts will come through. Actually, you know what? I let me just get the design. I have it already printed, so. Here it is. In what part of Germany do I live? Like in the south, like south of Germany. Baden-Württemberg, it's called, my state, near Heilbronn. Somewhere around there. So this is like the whole, this is like the outside portion of it, right? I printed it all white right now, but I will use some colors in the future. I hope you can see everything, yeah. All right, this is like the inside portion of it. The outside portion of it, this is the inside. So here's like the spring. And you put it in here. And you can put the outside thing over the inside thing. So currently, like the tolerances are shit. So currently when you sounds terrible. And it's also quite scary, honestly. So I need to file this down a little bit. And I also need to I need to change some things up on the design because some of this stuff is like way too tight. Okay, I'll stop. Really annoying. But yeah, that's something I was working on. If you were wondering why there are no YouTube videos for 6 months straight, it's just I'm working on peanut dispensers. That's where I spend most my lifetime on. Somebody asking if I'd studied dual. Yeah, I studied in a dual system. And it was a DABW. Was quite far away from here actually, but yeah, it was a DABW I studied on. And I dropped out of that because that was too much. Like honestly, don't go there. Like if you want to do if you actually want to learn engineering and not just run through there. I mean, you like, I'm not saying everybody who comes out of the dual study system is like, I don't know, worse at engineering. That's just simply not true. There are probably great engineers coming out of there. But what I'm saying is you get yourself into a kind of disadvantage at that point because you have like zero time for any like outside projects, right? And I would say like 90% of my knowledge I used at companies I worked at comes like from outside projects and not from the university itself. So usually like the kind of stuff like Fusion 360, nobody teaches you Fusion 360 when you study electrical engineering. There's just no way around it. Nobody teaches you that stuff. So you only learn the stuff if you do it yourself. Also like PCB design and I don't know, LT Spice simulation stuff. Yeah, you can do the if you pass the exams, and you will also have some like training in LT Spice and Eagle and stuff like that. So you will actually do those things you will end up doing at the companies, right? But there's like you won't ever think outside of the box. You will only learn the stuff inside the box. So if there's any like the real world problems you are facing from a day-to-day as an engineer, you will never see them. You will never learn about them in like the normal university. the only way to learn about like the kind of problems that come up when you actually work on these projects is by working on actual like real world projects that are outside of university. Otherwise you like I want to do more than just, I don't know, be able to like build transistor amplifiers inside LT Spice. But that's the stuff I learn at university, right? Like I will learn like how to build like a transistor amplifier, how to build like maybe even a boost converter, right? But other than that, like there's not much more. I won't learn a buck boost. I can't go into any like specific direction, be like, oh yeah, I want to learn this more. Like there's no real option for that. And especially on a dual study system, like you have no time for that. You have no time for private projects and to be like, oh yeah, I want to learn more than what I learned here. So yeah, that's usually like where the main knowledge, like that's where the real engineering knowledge comes from. Like if you want to learn more than what is taught at university, yeah, and that's actually the stuff you, I don't know, grow on kind of. Yeah, somebody's writing formula student. Yeah, Andreas, I know what you mean, but I also want to be part of formula student at the beginning, but then I heard that nobody gets to actually ride the car, even if you're like an engineer working on that stuff. So honestly, there's no interest from my side. Like I want to develop products that people actually want to use later on. Like, yeah, this thing is fucking stupid, right? But I'm quite happy if somebody actually ends up using this. So, but like the stuff I usually work on, like electric vehicles and things like that, I'm only interested in because I want to have people that actually use this in the end. Do I live in my own apartment? Basically, yes. Yeah. I actually lived in like a college dorm before that. Like there are some videos actually of me in the college dorm. Like this one video where let me show you. So there's this one video from me. Let's go here. Let's go here. So in this video, I actually blew up. I actually blew up the the circuit breakers inside my college dorm. Let me find that video right here. I think it is. Yeah, that's the video. Let me see. Okay. Let me find that. Let's see. Okay. All right. I think it was somewhere. Yeah. Okay. Yeah. Okay. Yeah, that was it. So this was like in the middle of the night, like at, I don't know, 3 a.m. in the morning or 1 a.m. in the morning. I don't know. And me and a friend were in my college dorm, and I was like testing out the first version of my spot welder, and I was testing it out and hitting it again, and you can see like the lights flashing up and down. I was just testing it, right? And this was like the first time testing it, and I just I connected the wires together with like a I don't know, solder wire or something that I want to have something that just burns away quickly. So that was what I wanted to test out on. And by the way, it wasn't because of that. It's because of the opening coil has such a low resistance that when you, let's say that you imagine the sine wave, when the sine wave is at this highest peak and you switch on this thing, the triac is a non-zero switching triac. So as soon as the voltage is very high, it switches on and the current just shoots through the roof, and triggers any circuit breaker. That's why this thing will blow up any circuit breaker. So this was like in the middle of the night, and we were trying out this thing, and yeah, we blew up the circuit breaker in the middle of the night in my college dorm. That was fun. Yeah, actually, like, but honestly, like, the reason I print this in white, like, honestly, I know that the quality is less good. But the reason I printed this in white is because I had so much white laying around. Like, what should I do with it? Like, I didn't buy it. Like, this was from a company I used to work at. They switched 3D printers, basically. They switched from 1.05 millimeters to 2.85 millimeters, I think it is. And now they need to throw out all the old filaments. So they came up to me and were like, "Do you want this stuff? Like, otherwise we have to throw it away, right?" So this white stuff is not this. I didn't buy this. I wouldn't buy white filament, honestly. If you have a good 3D printer, like, honestly, buy whatever color you like. But if you have a shitty printer like mine, I think the quality is way worse with bright filaments, especially white. Ja, okay, Andreas, aber so Andreas is saying that he would say that he got time for projects, but I would like to know what kind of projects. Like, I don't know anybody who worked who did a dual study system and was actually capable of, I don't know, running, like, getting anything big done. Yeah, you can maybe, like, on the weekends have some time, but most people I talked to, like, I don't know, they were pretty stressed out. Maybe you have, like, a very high stress level and you're, like, I don't know, better at that. But for me, it was too much. Like, honestly, I would just want to have fun also sometimes. Like, I want to have, like, a free weekend maybe every now and then, and be able to do stuff other than, I don't know, work on CAD models and PCBs and stupid shit like that. Hello, Nailu. How are you doing? What am I making? This is a nut dispenser, a peanut dispenser. This is the greatest invention of all time. I actually stole this from somebody. I hope nobody notices it. But this is you push down on this, and then a peanut falls out. In this case, no peanut falls out because there's no peanut inside. But they should. But the tolerances are pretty shitty, so there's no clearance. So I need to make some changes to this design, definitely. Yeah. All right, I think, guys, like, honestly, I'm done with this design. I will now walk over to my 3D printer now, start the printing process. Ja, also kein Ding, verärgertes Spielen. Yeah, I honestly, I honestly like that people can now share their opinion and stuff like that online freely. I have to say right now, like the last companies I worked at, like, I can't share any experience about them right now because it's either on the NDA, and also I don't want to talk about it. Like, honestly, I could, like, there are always, like, negative and positive experiences you're gonna go through, and there's obviously, like, big red flags you want to avoid. Like, there's big things that you should be aware of, and I will mention them, right? So if there's something, like, really big and, like, big red flag you should definitely avoid, I can talk about stuff like that. But in general, like, in the long term, you will always I don't want to have a YouTube channel talking about, like, every small critiques of, like, I don't know what any company does, because I also like honestly, some of the companies, like, even if I think they did something bad, and even if I think they did something shitty, I definitely want to work there in the future, right? There's like who does, like, the least worst things. Like, it's always about, like, yeah, you know, like who's trying the hardest to be not bad, because like in generally like every company kind of has like a downside to it. You won't find like any company that is like perfect fit for you, like never. That will never happen. Like that CEO must be yourself, otherwise that won't work, because the CEO is always going to have like a kind of different opinion than you, kind of prioritize different things, and you might disagree with him. So unless you are him, you won't be happy with any company. So in general, you have to find out like what's the least shittiest company for you. And I think every company is kind of like shitty. Even if I did one myself, it would be shitty, like to others, not to me. But yeah, so. All right, I think we're done for today. Yeah, let's actually look at the battery pack now. Let's gaze at it once again. And then I'm going to turn off the stream and play some, I don't know, play some Counter-Strike with mates or just talk to them, something like that. Let's render like a beautiful frame. I'm going to make this like the thumbnail maybe. I like honestly I don't want to upload like long live streams on my YouTube channel, but some people asked for it, so I'll do it for now. So let's render this out, and this is going to be like the thumbnail of the video in the end. All right, I think I'll wrap it up here. We're done with the design. Maybe I'll get back to you guys once I actually printed this. You know what? Come to think of it right now, I actually wanted to do like also like the mounting system, because currently it would be only mounted like there's no mounting system attached to it. So let's actually keep the stream going. I want to design something to this. This will be a quick change, but so we don't have much space on here, right? There's much space. So we have like a simple hook designed to this whole thing. Check the length of this. The total length of this is currently 137 millimeters, right? So it's 137 times 2 times 2. And in total we had 300. So it's 300 minus that. So it's 2.6 centimeters still of free space. That's not a lot, but we can work with it. So what I think of is electric inline skates. So I don't think electrical inline skates would be a great idea. Let me draw a human for you to illustrate my point. Let's say you have human. You have human on bicycle, right? Oh god, I don't want to mess up bicycle frame. Something like that. Right. Right, I'm the perfect bicycle. All right, you have humans sitting on here, right? Let's make the human red. Human is sitting on here like this, and he has his hands to the handlebars. So he has like 2 points of attachment right there and right there. They're way more spread out, right? Usually bikes are like, I don't know, I don't care. Okay, but let's say it's just for the sake of it. Human goes like this. So you have 2 points of attachments right here, and also kind of like here. So you have like if you draw this out, you have like, you see the leverage you can do, like it's basically from here to here. Like that's the amount of like torque you can apply to, like, let's say the e-bike rips out from underneath, you put a lot of pressure on it, like now all the torque is basically here's the center of gravity of your human, and now all the torque is basically just ripping him on his front and there. So there's not much point of him tipping backwards, right? All right. Let's say you got human on skateboard, electric skateboard. They are quite long, usually longboards. So like this, you could like your motor and drive system. Yeah, I'm so good at drawing. Look at this. All right. Yeah, that's the perfect longboard if I've ever seen one. All right, makes human red again. Human usually stands like this on a electric longboard. Whoops. Now that human is way bigger than the first human, but we don't care. The remote on here. All right. Okay. Now you got 2 points of attachment right here and right here. So you're attached on these 2 points. So now all of a sudden your the set point center of gravity is right here. So when this thing pulls forward, you have like a, I don't know, you get the point, right? It's like this and like this. So also here the torque, like it's already pretty big, but it's not too terrible. Now let's imagine the last case, right? It's like rollerblades. Okay, you got rollerblades. And the people I've seen that coast, oh my god, it's so ugly. I love the drawings. They are amazing. Okay, all right. Last human. Rollerblades. And they usually go like really close to each other, right? And now all of a sudden you're putting like all this torque on here, and like there's no way for him to counter any of that. There's no leverage. Right here you have like there's like some kind of, so how you would need to ride electric inliner skates would be like to put another foot back here and ride like a maniac. I don't know how you would do that. Yeah, you need to like put your feet at 2 different positions. So how the hell you gonna pull off that? That's like super annoying. Electric inline skates are not a thing you could do, I think. Like just imagine going up a steep hill with that and accelerating. Like that's not possible. You'll fly on your ass. That's not how stuff will work in the end, I think, at least. I never tried it out, but that's how I think it will work. I could try it out, but I think this is not a smart solution. Also, like inline skates are super dangerous, like the smallest pebbles and whatever, and they yeet you off your feet and you will fall so hard. Will I stream CS? If you guys want to see me play Counter-Strike, we can play Counter-Strike. That's true. So also, if you want to add me on Steam, you can. No, but maybe later on. Sure. For now, I want to finish this really quickly. So what I imagine would be like really cool. Like we can now have 2 mounting points. So the space left is basically, yeah, we have still some space left. There's like 2.6 centimeters, so 3 centimeters at least. Like that's. So what I would do right now, this is on this side, right? So I would attach like a hook to this side. Let's design that. Something like that. Let's go for 20 centimeters. I just want to make a rough sketch of the idea I'm currently having in my head. So Let's go like this. Let's go like 3 should be enough. So let's go like this, and let's go like that. And let's do like a line right here from there to here. Like 3 millimeters. Also here, 3 millimeters. And then something like that. All right. And now this has to have like a sliding mechanism. So something like that. This needs to be extruded by another 3 millimeters, let's say. Oh, let's go for 2. Something like that. All right. This is stupid. I need to leave this out. It's a conic curve. Something like, I know this looks even weirder. Actually go for something like that. No. I think there's no good way of creating something like that. Okay, so many people now asked if I could upload this as a video. I will leave the stream online. I will make a separate playlist for this, and I will leave the stream online. I'll see if I can, I don't know, make it not so very like, so that everybody just sees it, because I'm not quite comfortable with having like a lot of live streams of myself online. Let me think. This is actually stupid. Hold up. Oh, I can't even select it. Throw this out, throw this out, throw this out. All right. Let's go for like 4 millimeters deep, 5 millimeters deep. Go out like 3 millimeters. Something like that. And that would be like the latch for this whole battery. Right? So I don't have a perfect solution yet for this issue, but I don't need it everywhere. I just need it somewhere in the middle. Something like that. What the hell are inline foils? I don't know what you're talking about. Okay. Yeah, so I think this would be like the but this is stupid. Now it's attached to like this piece that's only like glued on here, right? That's also bad. I mean, what really happens is this only presses on here, so we should be fine in theory, but no, this is a bad decision, I think. Oh, I have a way better idea. Oh my God, why didn't I think of this before? Okay. Now here comes the real genius idea. Okay, I'm done with the sketch. This will not work. Boom. Be gone. All right. This is how it should be done. So let's first up as project this and that. Now we have this projected on here, and then we can make a offset. Now got the chain selection on. Let's go for 3 millimeters, something like that. All right, and then we can go for so now my idea is, so we'll make this simply exactly as wide as this one. So now we can basically push down the battery and then it clicks into place. How do we get it loose though? Need to push in from this side. The more I think about, the more annoying it gets. I can't figure out how to mount this properly. Yeah, I think I need to. It's part of the new SPO. Next year, next semester, we will have this as part of engineering, electrical engineering for sure. Yeah, I can't figure out how to mount this properly. I think so. I don't think I will get to a better solution right now. This is the best I could come up with currently. I need something that holds this from the top, right? It's like this piece is like mounted on there, somewhere on here on the top, like you know, like here on this plane. This piece is mounted, and this is like a fixture, and I need to make like some kind of mechanism where you can clip into this, and this is like the hard part right now. So what I'm thinking is maybe we need to clip from the outside, so that's easier because yeah, that's easier. That's way easier. Yeah. Okay, we will do this from the outside. So my idea currently is let's just model it out, right? We can make a new sketch. Something's wrong. I can fill it. Okay, this sketch was super useless. So this is my best idea currently. You will have like, this is our mounting plate basically. I'm just doing a rough sketch right now, but let's actually make it smaller a bit like this. And so this is like the whole mounting plate, right? And there's going to be another battery, just like this one, exactly like 180 degrees turned to this, right? So it's going to be two batteries, and so one like this, and the other one is going to be like sitting exactly with like the blue piece, like 180 degrees towards this. So that's going to be sitting inside the electric scooter down there. And on the other side, we will cut one of these things in half, or maybe even less than half. We make like a 1 centimeter wide piece out of this, probably. Let's see. Yeah, that would work. So we make like a 1 centimeter wide piece of this. In theory, you could also 3D print it, but then it wouldn't have the stiffness this thing has. So let's imagine we have this on the other side, right? So still have some space left. The space left we have, let's model this out. No, I don't want to do this. So the space we have left is basically, let's imagine our second strip, like this is the 1 centimeter strip right here, right? 80 millimeters, whatever, doesn't matter. And this thing has like a distance to that. Oh, hold up, that's wrong. We have 26 per side left, divided by 2, we have 13 left. Yeah, okay, 30 millimeters left. So this is going to be looking like that, and then 13. Boom. So there's not much space there, but we can use this. I think we will make this even smaller, right? Okay, let's imagine this is even smaller. Let's imagine this piece right here. Let's say this is also like 15 millimeters or something. Let's also I can't select this. Okay, this is stupid. All right, I have no idea. Okay. Let's do it like this, and let's go 1 millimeter new body. All right. So let's just imagine how we could put this in here, right? So in theory, you could, the batteries should press each other to the outside. So they sit back to back on here. So the thing that now we need to have something that's like hooking onto this from this side. There's almost no space in there. Well, or I just need to make like a permanent fixed battery in there. I don't know. This is super difficult actually. There's like no space in there. I want to have like a where you press on there and the battery just pops out. But there's like no space in here. Like honestly, this is the amount of space we have. Like this is the playroom we have, right? Yeah, 3 millimeters. That's nothing. Small magnets. Actually, you know what? That's not too bad of an idea actually. How strong can these like the shear force? Like that's the main issue with magnets, right? The shear strength. So when two magnets are attached to each other, they have a quite high shear strength, but like through vibrations, like the issue is vibrations are infinitely strong sometimes. Like you could ride over rubble, and like you can get like spikes of like 10, 30 Gs or something. Like the spikes of the acceleration of the scooter can be like insanely high. Like vibrations are insane sometimes on these electric vehicles. You don't even realize that, right? So it's like you build something. For example, a lot of my vehicles, like my electric longboard, for example, I later on realized that connectors were rattling loose, even though I was like, they are firmly pressed in there, right? They shouldn't rattle themselves loose, but they do. because there's like a lot of vibrations in there. So let's design something around that. Let's make like a simple solution for that. I don't think batteries will do the job, I think. Like a very smart solution. We need like a hook. Spring-loaded lever. That's actually smart. But then again, how do you like open it? Like there's like again there's only 3mm gap in here. That's kind of annoying. I think there's actually even more space than just maybe I need to, I don't know, expand it a little bit, because in theory, like there's, if you look at the underside of the scooter, like in theory I could maximize the amount of space I have on there a little bit. Like look at this, there's actually like here there's just weird stuff going on, and I measured from somewhere around here to somewhere around there, and I left some slack in there because, you know, stuff can get pretty tight. This is annoying. Spring-loaded lever would be probably really smart, but then again, like, how do I could jam like a screwdriver in there, and then it would open, and if you pull out the screwdriver, it would close back up. But that's stupid. Like every time you want to change your batteries, jam a screwdriver in your battery. That's kind of weird. Not too easy. I mean, actually, you know what? I want to remeasure that. I want to like, oh, Kudle. I don't know. Thank you so much for the €2. That's really nice of you. Thanks. Yeah, you know what? Actually, let's remeasure that. Like, I could just run over there. So I'll be back in 1 second. I'll take a remeasurement of that situation and tell you guys if this will fit or not. Measured it out again, because earlier I was like kind of planning already with some tolerances. There's actually 31, so this right here from here to around there. So we need to draw, like, imagine like a line that goes like across here like this, from here to there, 31mm. In theory, we could also, like, I don't know, remove this stuff back here, right? There's a lot of free space still there, but the VESC also wants to have like a housing, so that's kind of yeah, kind of have to make space for that. And there's also going to be probably an Arduino in there somewhere. So this is honestly, like, I'm not even kidding, this is like the hardest vehicle I've ever designed, because every other vehicle I've ever designed before that was like, I know how big the stuff is, and now we may design a casing for that, right? So you go the other way around. It's way easier, right? You just plan out, you press it as compact as possible, just put things where things should be and where they make sense. But now it's like retrofitting. It's like taking something that wasn't meant to do that and fitting in a battery. Yeah, all right. I think so. Let's make like that means we have like 5 millimeters more of space, right? So let's plan with that. So in this sketch, no, it wasn't this sketch, this right here. So we'll make, let's see, 5 millimeters more plus 5, like that. All right, now we have some more space at least. So let's see how thick this wall is again. So this wall is, yeah, I also don't want to make this wall smaller, right? It's like, it's not too big. 1.6 millimeters, right? Okay, I'm not making that smaller, so that's a no-go. But now I have some space at least. There's something, there's some space in there. So what I would design right now is like a small, like lever kind of thing. Yeah, that sits, that's, yeah, okay, I think I have an idea how I want to do this. All right, let's create a sketch. Let's actually make like a freeform thing. Let's start somewhere around here, somewhere down here. I just deleted it. Nice. All right, let's do this again. So we need like a 1.5 or 2 millimeters wide. Oh, I'm just realizing there's another issue. So when we're 3D printing this, the printing direction goes from top to bottom. So I see. Somebody had a great idea. So Veragterspion, thank you for your idea. So he thinks of something like something turnable that you turn like a screw that locks this into place. This would also be like a nice idea actually. Let me think of that for a second. Yeah, you could make it quite thick and that would work. You would need like in this case, I think you would need like a screwdriver to access it, but it would work. So Autodesk Inventor and Fusion 360 difference. Fusion 360 is more like towards like the things I do. Like I'm not a mechanical engineer. Like the mechanical engineer somewhere here, somewhere here. Mechanical engineering is like when you actually do like more complicated stuff. So Inventor has like a lot of tools. They are specifically tailored for like mechanical engineering. I don't know, maybe like I don't know exactly. I haven't used Inventor, but I think it's more like intuitive. It's more like SolidWorks when it comes to like the workflow. So you can just, for example, if you design a gear or something like that, I think it's easier. Also, if you design like very complex like load simulations, things like that, I think there's some benefits to Inventor. I don't know myself. I never used it, but Fusion 360 is like for the general purpose, like for designing, because you can do like these free floating surfaces, right? You can do like I don't know, design a car from the outside or something. That's more for like designer work, and the other one is more for like mechanical engineering kind of work, I would say. But I don't know for sure. Like honestly, it could be a little bit wrong. But yeah, like a twisting screw, like that would be fine. That would be like a good idea. That's not a bad idea. Like honestly, like that's like my favorite thing I've heard so far. Mm, yeah, but no, I think I'll have to go for this one. Reason being, um, I don't want another part actually, but that's like also the issue if you print this, like you're printing this from top to bottom, right? So this is going to be terrible. This is going to be like really really bad when printing this stuff because it's like the layers are on top of each other and it's not really strong in that direction. So yeah, no matter how I think about it, like I'm having really big pains with building this actually. Like this is not something I like to implement here. This is not a good solution either way. Come to think of it, like it only. I want to try something. You know what? I want to try something. Um, let's actually delete what we just did. Let's start off something like this here. Sketch, rectangle, like here, and do like a 3 mm wide and like I don't know 10 mm long channel. This is going to be quite weird, but I think it will work. So I want to make this two parts because filament, when you print it, like this is printed like this, so the printer goes around like circles. So obviously when you go like circles, like it's a lot stronger in the X and Y direction. So I can press on it really hard and it's really strong. But as soon as you like tear on it, like if you tear on it, it rips instantly. Like here you can see this right there, it ripped. That's not the only issue with this design, but so so that's why you always want to print in the direction you're stressing the material, right? So in this case, I will make it a second part. So this is going to be like plugged into the other one and attached with some glue. I think this is going to be the easiest solution, the easiest way out of this. Like I'm honestly like I don't have any better. Actually, let's not do that. Let's do an offset. The offset can be quite big. That can be like 0.5 millimeters. Ah, that's too big. Oh, 0.3. That's yeah, that's okay. No, that's actually still more than enough. No, let's do 0.3. That's fine. And then another one like this. It's going to be like I don't know, 4 millimeters. Oh, that's too big. 3 millimeters. And even bigger in this direction, like 10. Oops. Yeah, okay, sounds about right. Looks really weird. Okay, works. So this is going to be like an even weirder design now, but I think this will work the best. Honestly, yeah, that will work the best, I think. So we can design our spring now. The spring is going to looking like something like this. So something like that. All right. Something like that. All right. Oh shit. All right, and now, hmm, that's probably too wide. Let's actually check that. 2.8. This is only allowed to be 2.5 or something like that. All right. So the total width of this is now 5.5, and the gap between here and there is 8. So there's still space in there. So let's make this wider. Let's make this, again, let me calculate. That's 7, that's almost 8 millimeters, right? So from here to there, that's 5. Well, let's make this 3 millimeters. So, like that. Yeah, and now what you can do is let me think of this. Five 5.5. Something like that. Okay. And yeah, so that should work. All right, I'm happy with that design. So we need to finish off these parts right here. And also, like, I don't like this corner right here. I don't know why this happened. But just make a line from here to there. Actually make it even bigger. Okay. Sounds about right. All right. This is 55 millimeters wide, so um I think I already answered Kudole's question. So yeah, I think like again, I don't know if I'm really off with the chat, but Inventor is more for like the mechanical engineering side. So this is more for like designer top. So mechanical engineering is like here, and this is like here. It's like way more difficult. I think the main difference points, let's actually look it up because I'm interested now. 360 difference. Yeah, here. Inventor will provide you with a wide range of very complex objects. Yeah, that's, yeah. Here, for mechanical projects. Although similar, Fusion has a bit more fresh look, and Inventor is more stable and traditional. Okay, apparently there's the difference isn't too big anymore. But as far as I know, like Inventor has like way more, like it's more for mechanical engineering. That's all I'm trying to say. You want to connect these two 3D printed battery packs back to back without rattling, but easy enough space for it. So there's actually still space. Let's actually look up the picture, right? There's, I don't know if you can see, but the battery is quite slim, right? It goes down here. And so there's still space, like on the left and on the right, there's still space in there. So the cables can run through there. That's not an issue. I will glue them probably in there, or I don't know, drill some holes and do some zip ties. I don't know. I will find a way. But the main issue is finding a way to make it possible so that you can remove the battery, kind of. So they will sit back to back here. And on this side, there will be like a mechanical things that will prevent the battery from slipping anymore towards this side, and also slipping out. Obviously, that's like the main directions, right? It's it can be pulled either it can be pulled up in this direction, or it can be, hold up, that's the wrong direction. It can be like pulled in this direction. That's like the main two issues. And I think mine will protect against both of that. So if that makes sense. Yeah. So that's it. So yeah, what I want to see is how wide is this? Is 55 millimeters wide. So let's extrude this thing. Select this and that and this. Go somewhere like this. 55, right? No, it's both sides, two sides. So I would say like, I don't know, maybe 30. No, that's too much. 20. That's also too much. 15. And let's go on this side. Plus 15. Plus 15. Yeah, I think that will work. Look at this. I think that will work. All right, and the most important part, this is a new body. This is only like the springy part, right? And then we need to design around this. So let's open that again and extrude. So how I want to design this is, let's go just like this, and I would just go fully across, like, I don't know. It's easier to print probably even. Yeah, let's just do this. Join. And then do this again. This time go almost the full distance, like not 15, but plus 0.5, something like that. Boom. And then do this again. Go like this. Pull through 55 on this side. And the other side, pull all the way through. This is 55 minus 14.5. Something like that. So now this is our springy part, basically. You just slam that in there. spring. Yeah, you just slam that in there. This also obviously gets glued in here, but you can now print it separately. That's like the most important part. You can now print this as a separate part, and this will be way stronger in the end. And last but not least, we need to design like the piece that connects to this here. So let's do a sketch again. And now we want to have like let's do an offset. No, we need to project this first. Project this object. Also project this object actually. Let's do an offset. Like this, like that, and pull it in. Right, minus 0.5, 3, like that. Actually, you don't need that. You can go like, I think you can go like, no, you don't even need that. We can be really tight with this. So yeah, something like that. And I would also do like a quick splines. Oh, no, that's not how I want it. This, and this. Done. Yeah, it looks good. So in this case, yeah, I want to add something to the design, and that would something like .5. No, actually, let's do more. Let's do like that's too much. 3. That sounds good. So we need this thing. Let's just pull it all the way through, right? 55 millimeters wide. Boom. New body. We're done. And then let's open up the sketch again. This piece like that. Go in from this side. Minus 14. Go like this. And I want to join. Yeah, that sounds good. All right. And then I want to extrude this all the way through here. Well, actually, we don't need that. We only need this in the beginning and the end, right? So also we want to add like screws later on. So it would be useful to like have screw holes right here. So we can screw this together and put it inside there. Well, we need this on the other side. So it's 55 minus 55. And it's 55 minus 13. Something like that. Yeah, that looks really good. Oh, I see there's an issue with that. There's some clearance issue, yep. All right. fix this and fix that. All right, looks good. Oh my God, I joined them. Okay, I made a mistake right here, somewhere along this. Oh, oh. Let's do this metal bar end. And let's do this clipping point. All right, I think this is pretty good looking already. Yeah, yep. I think I'll end it here somewhere, because other than that, I don't think I can design anything more that's really useful. So yeah, that's it. I can show you one trick right here, because this battery, this thing will get printed from, let's see, from this direction, from down here. So what we'll definitely need is right here, we can do a chamfer on this and on this edge. I don't know how many millimeters this would be. Let's see. There's something preventing us from doing that. That's weird. Okay, all right. Yeah, okay. There's okay, there are some weird bugs with Fusion sometimes. I only want like a chamfer on this side, not on the whole thing. And Fusion just decides to do that. So that's weird. Yeah, I'm not going to do that, I think. We can actually model that in if we want, right? So to like the modeling, and let's see, I can do like a line from here to there. Finish sketch. First the spring, nothing changed. Then this, nothing changed. Then this, yeah, this is where it should be. And this. This. Yeah, that sounds good. All right. And let's add a chamfer up here, and I think we're done. Actually, let's look at the comments for a second. What do you think about a modular battery system? Every module its own control, BMS, and the modules can be stacked. So there's actually a quite nice battery management system that does exactly what you just described. The adapter one actually does that, so I can show you in a second. Where's my browser right here? I probably typed that wrong. Yep, here it is. This one, this can do that. This is quite smart actually, but it's also insanely expensive, and it's also, yeah, very big. So if you combine it with everything, this is like, it's also not a standalone BMS. You would also need the adapter controller to with this. So you can't just buy this single piece as a single piece and add it to your battery. But I think generally, like, honestly, the idea would be great. But it would also mean you would need like a microcontroller for every single module. So depending on how small you make your modules, that can be quite messy. But I talked about that earlier. I think it would be like a great idea generally to develop something like a modular battery system, where you have like small packs like these drills. If you buy an electric drill these days, they will be like in a size with a BMS inside and everything. By the way, these BMS systems usually don't balance, so these battery packs can be usually thrown out the window after like 300 cycles, but you can buy like battery packs that have like these components inside there. Yeah, but it's just not something I think anybody has taken up upon themselves yet. That's a lot of work, you know. Like developing a battery system, a good one, is actually like super difficult. Takes a lot of time. I worked at a company before a few years ago where I actually worked on like a BMS system for a short period of time, and yeah, it's quite something. So yeah, developing a good BMS system is quite the task. But exactly what you just said, right? Having like different kinds of like, if you have like a bigger vehicle, just add more modules to it, right? And they could be connected in series and parallel and things like that. That's the way. That's the thing. Yeah, that's very smart. That's something I already like. Yeah, I also thought about a while back. So yeah, that's something very good. I think that should be developed somewhere in the future. But yeah. All right, let's finish this up. I think I always say this. I always think like, oh yeah, I'm almost done, but then I realize, oh yeah, there's so much stuff missing. But now honestly, we have like the fixture. We kind of know how the battery will go in there. The reason I left some space in here, right? There's you know, this could be tighter. The reason I did that is I'm a little bit scared that otherwise, you know, this will articulate around that point back there. So let's actually do that. So this is going to be like articulating around this point. So if you want to, oh my God, won't that? Let me see. Let me think of this. How will this fit in there? Otherwise, we have to make this even smaller, right? But I mean, that's just in the end, it comes down to like how small do you make this point? I mean, yeah, that should work, right? I will make this maybe cut a little bit out of here because when you're comparing this, right, there's still like cross section. Let's say you put it in there and it turns around this point. It probably won't. It probably will turn around this point somewhere, but yeah. So that's kind of hard to think of right now, but I think that should work. I'm not sure. Otherwise, we have to make this smaller and smaller. Like this piece can be like, this can be made way smaller actually. So that would be like our last minute solution. But I think that's it for the battery, right? We have everything designed right now. I will print some of the stuff in the next upcoming days, and I'll figure it out. I'll figure out what works, what doesn't. So let's do that quick optimization I just thought of. Goes back here. Something like that. All right. All right, I think we're done here. Yeah, that's it. The real one, the self-management, just joined. Thank you for your huge donation. That's actually like one of my friends. So the more you learn, the more you earn. Never forget that. The more you learn, the more you earn. So we probably learned a lot today. That's why we earned a lot. No, but honestly, it was quite surprising to me that some of you guys even donated. Like honestly, I don't know. It was really kind of you. Yeah, was quite fun. Thank you so much for watching. Like honestly, this was really fun. Maybe we can do like, I don't know, some kind of gaming live stream in the future. Maybe we can do like more of these. I don't know, depending on how many people want to see this. If you want to see this in the future, like I'll do a couple more in the next upcoming weeks, hopefully. Every time I need to make like a big CAD model or, I don't know, simulate some things on the computer for a long time, I can, you know, give you some insights and show you the things I do. You know, for me, that's not much more work than usually, and maybe some people get some entertainment and maybe even some knowledge out of this. So, and I mean, I also get some knowledge out of this, right? So you guys gave me some great ideas, some great inputs on some of the things. Yeah. I think I'll continue this. This was fun. So again, thank you so much for watching, guys. I think I'll end the stream here. And yeah, I hope I see you soon. Steam now. All right, Steam. 1 second. I'll add everybody on Steam who wants to add me on Steam in the next few minutes. My Steam name is Steam Community Price Side. Let's go like this right here. That's my Steam account. I don't know if you can add me though. I think you should be able to add me. So if you want to play Counter-Strike in the next upcoming days with me, or I don't know, something, if you want, you can add me right here. That's my ID, PriceSide. Just go steamcommunity.com/ID/PriceSide. I don't know. I will add everybody who's sending a friend request in the next few hours. After that, like I get friends requests every now and then, and I usually don't. Yeah. Accept them all. So yeah, steamcommunity.com/ID/PriceSide if you want to add me. Otherwise, yeah. Again, thank you so much for watching, guys. It was fun. I'll put the stream in the playlist or something, and yeah, we're done here. So bye. Thanks for watching, and thank you so much for the donations again. This was awesome. Bye.